Hello everybody, welcome.
Hi.
My name is Erik, this is Ruud.
My name is Ruud.
And of course we do the social distancing again, so Ruud is like 5 meters away from me. Actually around the corner. And today we're going to answer the question, is MSI making power supplies? It's a simple question, but maybe a difficult answer. Anyway, first a little bit about the giveaway. We have a giveaway again, and last week, Ruud, maybe you can show the chair?
Oh yeah.
Yeah, so we're not going to give away this chair. Last week we already gave away one, and we gave a collector's edition from Assassin's Creed Valhalla. But we got a lot of positive reactions, so we decided today to give away more Valhalla game codes. Really nice game. So on both YouTube and Twitch, I need to think a little bit, YouTube and Twitch, we have the chatbot spamming the link each like 5 or 6 minutes. You can click on that, or you can go to, what is it? MSI.com, MSI.com/2/insiders. There you insider. There you also can find the giveaway. And yeah, during the live stream we will draw some lucky winners. So back to the topic, Ruud. You are here for the technical support.
Yeah.
So you know, we had this idea for a live stream about power supplies already a long time, and my initial idea was like, can we make one smoke, you know, go up in flames or something.
How to go over the power limit.
Yes, indeed. But that was not a good idea, they told me, because then our stream would also go offline.
Insurance and stuff, yeah.
Insurance, yeah, indeed. So today we're going to talk about power supplies, about also the MSI power supplies. So that's still no answer if we make them or not. We just say we have MSI power supplies. And what we're going to do is we're going to prove to you, and I already have here, we have a real-time power meter. Real time, it refreshes like each 2 seconds or something. We're going to prove to you how strong power supply you need, because on the market you see like 1.2 kilowatt and probably even higher power supplies, but I think most people don't need it. And especially with the new RTX 3080, 3090, a lot of people, you know, they like, oh, I need to upgrade. But do you really need to? And what do you need to pay attention to when you upgrade? And you already see a test system there next to Ruud. This is now configured as an entry-level test system. So during this live stream, we're going to show you what like all the components are using. We're going to benchmarks. We're going to show you some tricks how to let it consume less power, and we're also going to upgrade it. So, and the power meter in the right corner will show you how much power, what the power draw is. It's now running in desktop mode, right?
Yeah, it's just sitting idle at the desktop. And
84 watts. I mean this.
More or less, yeah.
Yeah, more or less. Just let's start maybe. Let me check you see the chat as well?
Yeah.
Explain the 12 volt, 5 volt. Yeah, we're all getting there. What is the rating of the power supply?
Yeah.
Platinum, titanium, a lot of questions. Yes, we are all going to talk about that. So let's maybe first talk a little bit about this, because to answer your question, is MSI making power supplies? Yes and no. Because actually not a lot of brands are making power supplies. There are only a few factories in the world, like Seasonic, FSP, CWT, who are making power supplies. They are the factories. What we do, we design the power supply. So we have our requirements, we have our wishes for a power supply, and that's also what the other branded products do at the right side. They don't own factories, they just get the power supplies manufactured in the same factories like what we do. And yeah, we already used the MSI power supplies earlier. So is MSI making power supplies? Well, we're not manufacturing them, but yes, we're making them. So you decide what the answer is. Let me see in the chat. Japanese capacitors? Yes, we're all going there. Are you from Spain? No, I have a Dutch accent, so I'm from Holland.
Me too.
Yeah, indeed. So let's talk a little bit more in detail. Why do we make power supplies? Well, I think most of you know MSI already some time, and in the past I'm now working 18 years, and you, Ruud, 19 years or something?
Almost 21.
Almost 21?
Yeah.
So you're working
Yeah,
21
it's
years for
ridiculous, I
MSI.
Sorry?
You're already working 21 years for MSI.
Yeah, almost, yeah.
Wow. So me then 18 or 19, right?
Yeah, 19, I think.
Anyway, you know, when Ruud and me we started, we only had main boards. Then we started with VGA.
Yeah, very few VGA.
We did a lot of products you don't see now anymore, like opticals, like the CD-ROMs, DVD drives,
TV tuner cards.
MP3
Remember
players.
those? Yeah.
We had a lot of stuff. Anyway, but in the recent years, MSI became from a more like OEM manufacturer to a brand, a gaming brand. And now we have an ecosystem, and we're adding more and more products to it. So I think you already know the VGA cards, the keyboards, mice, water cooling, cases, and recently also the power supplies. And yeah, this is just to make the whole ecosystem complete. So you can wonder what we're going to do next. Well, maybe next year. That's a question mark. I'm checking the chat. People like the dragon. Yeah. Well, we're probably not making that one. Nowadays with COVID-19, there are not a lot of physical events. But if you ever have the chance to visit a physical event, like a gaming event or some other type of events, please go there because they're throwing them in the audience and they're the giveaways. So that's about the assortment. Let's talk a little bit about what kind of size power supply. Ruud, you have the small one, right? It's not really the smallest one. Let me see the detailed cam.
Oh, the detailed cam, yeah.
Yeah, so this is a SFX power supplies. It's really small, and that's for small form factor. So you talk about mini ITX cases.
Yeah.
It can. I think this is Corsair SF
600. Yeah.
600. So it can still do 600 watts. So size does not always translate to wattage or performance. Then you have the Flex ATX, and they're the smaller ones, and basically they come with an adapter outside. So and we are now at this moment going to focus at ATX power supplies. Ruud, maybe you can also show the MSI one, or maybe we should do an unboxing.
Well, we have one here. Well, we can also do
do an unboxing.
Yeah, okay. The real unboxing, because it's still in plastic.
I think people like that.
Yeah, let's hope it's all complete, because we haven't opened it yet. Let's peel this off.
Are the new power supplies coming to South Africa? Yes.
Really? Do you know?
Yeah, worldwide shipping.
Okay.
I've seen some, I think in Europe already arrived.
So
okay, I will switch to the detailed cam.
Oh, yeah. Don't.
Yeah, so there is some manual inside.
Yeah, manual inside, and then also important information. You don't need that.
we never read that kind of stuff.
It's just some security things. So don't open it up. Don't pour any liquids in and stuff like that.
Can we test that?
We can, but then I think the stream will end.
Yeah.
Okay, there's also plastic bag, and then there's the power supply.
I see somebody is asking, can we get access to the slides you're showing? Well, most of the content is from our product page, and later you will see some other information, like some benchmarks, but everything is from the internet or from our own testing. You can make screenshots.
Yeah, and it's on YouTube, so you can always watch it back later.
Yeah, good question. How should one go about choosing a PSU? Yeah.
That's what we're trying to answer today.
That is what, indeed, that's the topic of today.
Normal gaming and stuff.
Yeah.
I mean, yeah.
So, what's in the bag?
The bag has a lot of cables. This one is a US or Taiwanese power plug.
I think that is in UK.
No, it's a US, or in Taiwan they also use this one. Yeah.
Yeah.
We don't use that in Holland, so it's no use yet. Oh, I almost lost some screws. The screws are here to put it in the case.
Yeah.
So mount it securely. And then there's a bag of all kind of loose cables, because it's a fully modular power supply. Oh,
It should have RGB by now. Well, that's an interesting topic.
Yeah.
Because we know RGB is making everything faster, but the power supply doesn't need to be faster. And today we're going to look at how much power RGB is actually using.
yeah. Yeah, okay. We will try to show it, and yeah,
Yeah.
let's wait for that. So the power cables, are those interesting to
Yeah, a
show? or-
lot of cables. We will go later in more detail.
I think it's also in the slides, right?
Yeah, so maybe first talk a little bit about the size of the power supply, because this is well, you have different formats of ATX power supplies.
Yeah.
You have a bigger one as well?
Yeah, we have also one huge one, also more capacity. So this is a Corsair HX1200i, and this one is.
Oh, maybe you can also put the SFX on the screen.
Yeah, we
Maybe.
can
Stack them.
stack them. Yeah, a good idea. Like that.
Yeah.
Maybe just tilt it a little bit. So that's the
And-
difference.
And the middle one, which one is it?
This one is our A750
750, okay.
GF. Yeah.
Yeah. But
So-
like what I said, size doesn't matter. I mean, you have the smaller ones, you have more powerful, and you have also 600 watt bigger. So,
Yeah.
but this is important because if you have a case, you have your drive base over there. Can you maybe turn around
Yeah, can.
the power supply, sir?
I can do that all together. Right. And they're all fully modular, so
Yeah,
you can
these are all
also
modular,
see them.
and that's important because you need to have, in your case, the right space. So yeah, watch out with length, the size of a power supply.
Yeah.
Because with modular design, of course, you can easily connect only the cables you need. But still, if you first build your power supply in your case, let me go here, and then you still need to connect the cables, that's not going to be easy. But yeah, so size matters in this case. In this case, wow.
In the smaller cases, you will notice
Yeah.
the difference between a longer power supply and a shorter one. The SFX is of course only for SFX cases.
Yeah.
It's a different spec.
I think
Different
also
mounting holes.
important is single rail and multi rail. It's a little bit technical. Later, Ruud will also you will open a power supply, right?
Yeah.
With the power on,
What? Sorry, with the?
power on.
No, not with the power
Ah.
on, because some parts they bite.
Yeah,
Yeah.
they bite.
I don't want to risk that. No.
Yeah, so this is about single rail, multi rail, and Ruud will also later talk about it. But basically, single rail is you have like a highway. You have one lane to which all the power goes, and with multi rail it's split up in more rails. And you can recognize like this on the PSU label. So if you look at the 12 volt on a single rail, you will see that all the power is basically on one rail. On a multi-rail, it's split up. And there is no good or bad, because they all have their own purposes. If you look at single rail, everything is on one rail. Basically means it's very useful for overclocking, because if you, for example, connect your PC or your motherboard or your test setup to one rail, to a multi-rail, I should say, and you are going to use like 500 watt, probably it will not run stable. On a single rail, however, for overclocking, and then we're talking about extreme overclocking, right, Ruud?
Yeah, I think the single rail is mostly for the high end and the higher capacity power supply.
Yeah, then you talk about 1 kilowatt, 1.2
Yeah.
kilowatt,
Yeah.
and also overclocking.
Also, the multi-rail doesn't need to be unsuitable for overclocking. It
No.
just depends on how strong are your rails.
Yeah.
So per rail power or current capacity.
Yeah, what's important is, for example, if you look at 37, 38, 3090, and then same case is for the new Big Navi which just launched, is how you connect basically the rails to
Yeah.
your GPU. Because if you look at 3090, Ruud, maybe you can...
I have the 3090.
Oh, you have a 3090?
Yeah, I can show you.
Even better.
Have to just grab it. And the 3090, Basically, there's different 3090s on the market.
Yeah,
of
maybe
course. This
remove
one is the
them.
Gaming
Don't need
X
them anymore.
Trio, and it has 3 power inputs, 3 8-pins, and they combined they can consume up to 380 watts on this graphic card. That's the maximum power limit you can set, and the default one is 370 watts. So that's quite a bit of power. And for some power supplies, a single rail would already be maxed out at maybe 350 watts or so. So then it's wise to double check your power supply, how much each rail can do, and put at least 2 rails on a card like this. But this is almost the most consuming graphic card out there. Of course, there are other models that have an even higher maximum power limit.
Yeah. So later we're also going to play with power limits on VGA cards to see what is how it works and why you need to watch out for that, right? This is not. This card is not meant for overclocking, so you cannot really go berserk on the power limits. But no.
It will not max out the power supply we're using today because that single rail is already 40 amps. 40 amp rail can already do 480 watts in total. So even a single rail could power this card.
Yeah. Stable.
Yeah, no problem.
Yeah. Okay. Let's talk a little bit about models and pricing because always everybody is talking about that. We have 3 models: 650, 850, and 750. So actually 650, 750, 850. G stands for gold, so they're all gold plus, and F stands for fully modular. I'm not sure who came up with that because I would say the M for modular, but anyway. And the A stands for ATX. So I see some questions in the chat. Are you going to make like mini ITX? We don't know yet. Maybe we will see.
Now also a question about non-modular.
Yeah, non-modular, maybe in the future. These are now the models we have, and so far as I know, this year we will not launch any new models, but in the beginning of 2021 you have again CES. This year it will be a virtual event, but yeah, who knows what we will announce over there. But yes, of course we're planning new models as well. These are the Euro and US dollar pricing. So US dollar is without VAT and Euro is including 20% VAT. So you have an ID. And we offer 10 years warranty on the power supplies. And yeah, we have currently, I will show you that as well. Let me switch this. So if you go to MSI.com and in the what's new, we have a menu. Do we have a menu? I still connected. Anyway, you click on what's new, you go to promotions, and you will end up on this page. And this is Assassin's Creed Valhalla bundles we are having with several products. So we have them with monitors, mainboards, liquid cooling, power supplies, and chassis. And if you click on the power supplies, you see the 3 models. So if you purchase one of them, you can. I think you need to register yourself the product with the serial number, and then let me see if that's correct.
I think you need to upload like an invoice.
Yeah, indeed. Yeah. You probably need to proof of purchase, etc., and you will get a game code as well. But today you can also win them. Actually, so last week we had a live stream about one of our new ultra-wide gaming monitors, but we also had Ubisoft here. So we had a Ubisoft in the live stream, one of the game directors. We talked to them, and then in the evening when I went home, I saw on the news that there was like a hostage situation at Ubisoft. So we're like, oh my god! Oh, really? But in the end, I don't know what happened over there, but they were safe. So nothing happened to them. But yeah, quite scary. Let me switch this around. So yeah, pricing maybe for some people. Let me check the chat. Where can we buy these PSUs? I believe in Europe they're already available. First batch, Asia as well, and USA should arrive soon, so that's in the coming week. So, do you have 1200 watts? No, not at this moment. and we're going to show you that most configurations for gaming PCs can run perfectly with one of these power supplies.
Yeah.
I mean, if you need for 1200 watt, that's like a TRX 40 segment with like 4 VGA cards or something. But
Well,
Ruud, I see
depends
you
on
think.
what kind of VGA.
Depends what kind of VGA, depends what kind of load, and etc. Indeed. Yeah. The capacitors from PSUs go bad. We will open it up. Yeah, we have Japanese capacitors.
Too quick.
Yeah, let me talk a little bit about 80 plus, because I talked with our PM, with our product manager, and he said, yeah, I mean 80 plus gold, that's really important because of efficiency. And here you see two tables. One is 115 volt, that's for USA and some other regions, and in Europe we have the 230 volt. The power supplies, of course, are automatically switching between the voltages. In the past you had a switch on the back. But nowadays this is all fixed automatically. And you see the efficiency levels. So if you look at bronze, for example, and it's important to look at the percentages, because this is the load. So if a power supply is used, let's take the EU, the table on the right, as an example. If a power supply of 80 plus gold is running at 100% load, it's 98% efficient.
89.
Of 89, sorry, in English, yes, 89. But if it's running at 50% load, it's 92% efficient. So this differs. And the sweet spot normally is around 50%. But what you can also notice, and this is not in the table, at 10%, it's not listed, but that's
Yeah, the spec is only for titanium. Yeah.
Yeah, indeed. Only titanium, that's what they defined with titanium. That 10% should also be defined. And you see that 90% for titanium.
Yeah.
If you go to this table, you see these are all kinds of levels tested. And to be honest, these are not MSI power supplies. We don't know what brand and how many they tested. This is from, how it's called, Energy Star, right? It's an organization which is all about power saving. And power usage. So they tested a lot of power supplies, and to be honest, I don't know which ones, which brands, or how many. But what you can see here in the table, at the bottom you see the load. So this is 10%, below 10% load, and you see the efficiency. So you actually see at 10%, most are between like 74 to 92% efficient. But below that, 1%, 2%, 3%, 5%, it's even worse. So,
yeah.
And you need to, of course, it depends on what kind of components you have. Ruud, maybe you can give some examples?
What do you mean?
Yeah, with what kind of components? If your PC is running in idle, because a PC is not
if you have
always really
integrated
running
graphics.
full load.
If you have integrated graphics and you have a CPU that doesn't do much, just setting the idle, then yeah, it could run maybe 20 watts or so.
Yeah.
This one has a VGA and okay.
And if you have 20 watts on a 500 watt power supply, that's far below 10%.
Yeah.
And then your power supply is not running efficient at all.
Yeah. But in the end, if you're only drawing 20 watts, there's not much to lose, you know.
No.
Even if the percentage is really bad, then yeah, you might lose like 10 watts. Then.
Yeah. And this is what they defined with the titanium level. So you get better efficiency, also below 10%. Maybe open one up, Ruud?
Oh yeah, sure.
Because I have here a picture of an open power supply.
Where is
Connected to the cable.
What?
Maybe put some power in there.
Yeah, to make it more interesting.
Please, don't do this at home. I mean, Ruud is a
Yeah.
technical, what are you actually, Ruud? FIE, Field Application Engineer, right?
Yes, exactly, yeah.
So you do all the troubleshooting, you do all the testing, all the marketing samples.
I would say I'm a trained professional, but no, I'm just hired to do this.
for already 21 years.
Yeah, but not trained or anything. Just
you train yourself. You do a lot of research. You test.
Opening stuff up is not something new for me.
Normally, if I open something up, it breaks.
Yeah. But watch out if you open up
No
power
RGB.
supplies, because if you just disconnect it from the mains power supply, then it's still loaded. There's some capacitors inside, and that can hold energy for quite some time. And the primary side, so the high voltage side, will continue to be in those capacitors, and once they unload on you, then you will feel it, and then you might jump in the air for a bit.
So feel it like deadly, or feel it like
No, usually
New
not, I would
haircut.
say, but I'm not gonna try it. This one came out of the box, so it must be already powered off for longer time, so I'm quite safe, I think. If not, you'll see sparks or smoke or whatever. Or me jumping up, that's also possible. So this is the inside. I think you also had a diagram.
yeah?
I'm not sure if we can.
So this is how a power supply works, right?
Yeah, this is like a block diagram to simplify what's going on inside. So basically the mains power supply in our case is 230 volts of alternating current. So you'll have a positive and a negative voltage in a sine wave. In the old days, the voltage would drop immediately, or was going to be converted to a lower power with a transformer. That would be in the older power supplies, but nowadays, to increase efficiency, they first converted to a at least that's how I understood it. I'm not an expert in the inside of the power supply, just a disclaimer. So they converted to a higher voltage direct current, so it will not be a sine wave anymore, or it will be an inverted sine wave only with a positive voltage. And that will be smoothed out, and that will be chopped up into a higher voltage alternating current with high frequency, and the high frequency is fed into a transformer. And the higher the frequency, the more efficient the conversion of the high voltage to the low voltage. And from the low AC voltage, there it will be converted to 12 volts DC. So
And that's what your computer uses, right?
Yeah,
Your
exactly,
motherboard.
yeah. So for example, the power supply feeds the CPU and the GPU, or at least the graphics card, with 12 volts. And those are the two most important consumers in the PC.
Yeah.
And from the 12 volt inside, the power supply also will make 5 volts and 3.3 volts. Some chips still use that on the motherboard.
So that's also what you need for drives.
Yeah. So if you have a Molex connector for old hard drives and stuff, it still has 5 volts and 12
And
volts.
the new SATA connector, that's also 12 volts?
That one also has 3.3 and
5.
12 or 5. I'm not sure.
Okay.
They used to have color, so.
Yeah, indeed. But now everything is black, right?
Yeah. All cables in most gaming-oriented power supplies are black. Yeah. So the inside, usually this is the hot or the primary side.
Can you maybe show the back side so people know the cable?
The power, the mains power.
Yeah.
There's a switch, so you can.
So
Turn
the
it off
difference
completely.
between Ruud and me is basically I pull out the power connector. I even don't switch off the PC. Ruud is just normally powering down the PC, then switching the switch over there, and then pulling out the plug. Mine is faster.
Yeah, but it's safer for your components and for yourself. For yourself, it's not a problem because it's only maximum 12 volt DC, so it won't hurt you a bit. But for the components, sometimes if you swap a CPU, then it will turn on by just inserting it, and then you just better switch off the power supply completely, and that's why this little switch is there. Also, the standby power of the motherboard will be completely shut off.
Yeah. And the holes in the back are also for airflow?
Yeah, this is for airflow, so basically the fan on the top.
Okay, the fan is on top, yeah.
Usually it's on the bottom because that's how you mount it in most cases. And most cases have the power supply in the bottom these days. In the past, it would be the other way around. It would be in the top of the case. Still, some cases have it in the top, but I think most of them are mounted in the bottom now.
Yeah, so this is a 140mm fan.
Yeah, so 140mm fan, so it just takes air from the outside and blows it in, and then these holes, it will expel the hotter air, and so it will come out of the backside of your case, and it will draw the air from the bottom of your case normally.
Max Bunny on Twitch is asking what kind of fan is used. This is a fluid dynamic bearing fan.
Yeah, it doesn't say on it, but
I know.
yeah, there's an F in the part number, so it could be right.
FDB.
No, yeah, it's a HA1425M12F. Okay.
So how do you say that? I also see a lot of heat sinks in there.
Yeah, there's some heat sinks. Yeah, first the power, the 230 volts.
Or 115, depending where you live.
Yeah, yeah. Let's say the mains will come in here. Then there's like some
AC to DC?
No, not yet. First there will be some capacitors and chokes. Or
So they
coils.
can make you cry.
Yeah, yeah. That's the same as sticking like a tweezer.
Screwdriver in the...
Yeah, a screwdriver and hold it in the mains outlet. Don't do that.
Yeah.
Also, if you open up this one, yeah, be careful because the primary side is dangerous and will give you a large shock, electrical shock. This part, there's a heatsink on it. I'm not sure if I can make it visible.
A little bit lower?
There's a
Angle
plastic
it.
foil in front of it. Maybe like that.
No.
Yeah,
Lower.
I was going for this one.
Ah, okay, yeah.
Yeah, that one is actually the bridge. So I think first the part comes of the power factor correction. So to draw as clean and efficient power from the mains, the power factor needs to be corrected, and that basically means that if you have all kinds of coils and capacitors attached to it, the voltage and the current will not be in sync. And if they're out of sync, they will just throw power from the mains to the power supply and back, which is inefficient and heats up the components. What the power factor correction does is basically create like a more load that's very similar to a resistor, so the voltage and the current will be exactly in sync, and that's also much easier for the electric, the power company to give you a stable voltage if you do that. So the power factor is something that's required by law, at least in the EU, and I think mostly in most countries in the world.
Yeah, so let me answer a lot of several questions.
Okay.
When are they available? They are already available in Europe and in, let's say, APAC, Asia. USA will probably be next week. Does RGB increase power efficiency? No. Well, this is about efficiency. The more efficient a power supply is, the less power it will lose, and power means heat as well.
Yeah.
So, and to cool that, you need a fan. So basically, an efficient power supply. Can I say? I mean, I'm not sure if that's correct. And the more efficient the power supply is, the more silent it will be.
Yeah.
But also depends on the wattage, right?
Yeah, of course. Yeah.
Yeah. Okay. Yeah.
But if you have the same power supply for like a 80 plus gold or bronze with the same load, then the bronze will output more heat because it is less efficient.
I used to open up power supply as well, but that's like a long time ago, maybe 20 years ago, and I don't recall they look like this. It's more like a lot of glue.
Yeah.
A lot of. So that's something from the past.
Yeah, they even have a black PCB and stuff. So that's something
Nice.
that I didn't really expect on a power supply, but these days they look very decent.
If somebody is RGB fan, we need RGB cables, stickers,
Yeah.
fans. A good question. So why not a Torx fan? That's a really good question. I know we're looking into this, but this is of course very difficult because if you go to a factory which makes power supply, they already have their vendors for fans, for the capacitors, etc. So it's like a menu card to pick off all the things to make your own design. Of course, you can get custom fans into power supplies or custom components. That is possible, but that takes time. So we're working on that. I'm not sure if it will happen and when it will happen, but for sure we're looking into the possibilities.
Yeah, so after the bridge it will just be DC current or DC power, and it will be chopped up into very high frequency AC again. So it's a bit weird that they go from AC to DC to AC again, and then
sounds
back to
inefficient.
DC. Yeah, it sounds inefficient, but because of the higher frequency, they can feed into the transformer. This is the main transformer that will output the power to the 12-volt rail. Because of the higher frequency, the transformer will lose less power, and therefore the whole power supply will be more efficient.
People in the chat, if Erik opened it up, it would already been broken.
Yeah, hopefully when I put it back together, I can still use it.
Are you
tomorrow.
going to use this one?
Not today, but
okay, good.
Probably tomorrow. Yeah.
Okay.
Then after the transformer, there's power switches or MOSFETs on the back of the PCB. At least I saw on pictures. That's why you also see some heat sinks here. I'm not sure if you can see it, maybe on an angle.
Yeah.
And those are on the back, so basically the heat sinks just cool the whole PCB. Once it's onto 12 volts, also some part of the PC still need 5 volts and 3.3, and that's this little PCB.
Looks like an add-in card.
Yeah, it looks like an add-in card, but it's soldered, so you cannot just pull it out. But that's what is created on this little card. And then from there on, you will see the back or the front, depending on how you look at it. Here are all the connectors that will your cables attached.
Can I maybe turn around, because then we maybe talk a little bit about all the connectors.
Oh yeah, sure. Yeah. And then you'll see the motherboard 24-pin connectors. It's split up into
it's
two
upside
parts.
down.
Oh, sorry.
Nobody knows.
My bad. Yeah. Don't know if it's focusing or not.
Yeah,
but
maybe a little bit back.
A little bit back. Better?
No. Anyway, yeah, good enough. I mean, the left two are peripheral and side. This is the how many watts? 750?
This is the 750 one. Yeah, so
okay.
That's 12 volt rails are 35 amps on the VJ1 and the VJ2. So these two.
Yeah.
So the top one is the VJ2 and the bottom one are the VJ1. But you can also attach the second CPU power cable to it. So there's one CPU power connector here. So you can connect the 8-pin 12 volt to your motherboard. And if your motherboard has a second one, you can also use this one.
I see somebody saying, so the ODM is Corsair. No. Let me see if I can show that again. Corsair is also a brand like MSI, and if you look at, I think it's the what is it, the RX or the RM series from Corsair?
Yeah.
Those are also made in the same factory, so that's CWT. Back to you, Ruud.
Yeah, next to motherboard CPU, you also have the VGA connectors. And if your CPU has enough on 8-pin, you can also use all 4 for graphic cards, depending on how many you use.
So let's maybe talk a little bit about the connectors. I put it here on the screen. Yep. If you have the 750 watt, you get one ATX connector, which is the 24 pin for your motherboard.
Yeah, got one here.
Oh, detailed cam.
So yeah, this is split up in 2. So this is what goes into your power supply, and the other side will go into the motherboard. Yeah,
so and this is a flat, we're using all flat cables. It's much more easier, and in the back of the PC, behind the PCB tray, let's say like that, to hide them. so they don't take
Yeah.
as much space. Also, the cables are a little bit more separated, so it's better for signal strength.
Yeah.
Um,
It's not really a signal, it's just power.
Yeah, with power indeed, yeah. So 4 PCIe connectors, 8 pins. So that is for your VGA.
Yeah, you have the 8-pin that goes into the power supply, and then you have a 6 or 8-pin. You can combine them to make an 8-pin.
Yeah.
And
And how much power can one cable deliver?
For this power supply, it's like 35 amps per rail, but yeah, that's you need to calculate that. I don't really know how much that is.
Yeah. But that's for VGA cars.
But officially, the ATX spec is 8-pin will do 150 watts.
Yeah.
But you can do more. So it's a real safe spec.
Then
With
8
cables
SATA
like this.
connectors.
SATA,
and,
yes. Where are the SATA?
A lot of devices are nowadays using this. Also, if you have like a
SATA,
USB hub, it's powered by this.
Yeah. So they also connect with a 6-pin to the power supply. It's not really focusing. Yeah, 6-pin.
It's a bit slow today.
Yeah, okay, it doesn't matter. Then you have the SATA connectors, the power connector.
Yeah.
And you have multiple of them. So
You connect
4 of them,
multiple
yeah.
hard disks, or well, hard disks, SSDs. And
yeah.
that is what I
Also
think
hard
is
disk,
one
yeah.
of the benefits of M.2 SSDs. They don't need these cables anymore. Because this
No.
only power, you also need the signal.
Yeah, the M.2 is better for cable management. You don't need cables.
Yeah,
Yeah.
indeed. 2 EPS connectors, that's basically for the CPU, right?
Yeah, that's another one for the CPU. So this is one.
One moment.
This is the 8-pin that goes into the power supply, and then you also have the 8-pin. But this 8-pin is also, you can separate them.
So can you explain a little bit how that is? Because some indeed are using 4 pins, some have 2 8 pins. Should I connect them always, or how does it work?
Normally an 8-pin would be able to, I believe it's like 284 watts officially.
Mm-hmm.
But yeah, it can do also more than that. And there are no CPUs that need that much power when you do regular load. So I think one 8-pin should power any CPU that's not overclocked.
Yeah, so in an MSI mainboard, if you have 2 8 pins, you just connect one and it can work, right?
Yeah.
The other one is more for overclocking and additional power.
If you do like LN2 overclocking or phase change or anything with high power, then power draw gets up quickly.
Yeah, because a
I'll
lot
show
of people.
you with this one as well. I mean, no, not with this one, with the next one, with the upgraded one. But we have another one, CPU, same thing, also 8-pin, and 8-pin that can be split up into 4. So if you have like a simpler motherboard or more entry level with the CPU that only draws like 45 watts or so, then a 4-pin is more than enough.
That's also what you see on the smaller mini ITX or ATX
Also,
boards.
yeah, 65 watts, also 4-pin is more than enough. Yeah. So
Okay.
anything with a Ryzen 5 or i5 without the K, then yeah.
And there are still some peripheral cables
Yeah,
for.
sure.
I don't know why we still include this. This is for like CD-ROM and floppy drive.
Yeah,
No, not
there's
floppy.
even a floppy one.
Is it floppy?
Yeah, there's no floppy drive inside, but the
Are you
power is
serious?
there. But I also believe there's some case front panel stuff that still use this kind of connector. Don't know why, but yeah. And also the regular.
Oh, one moment.
The ones
Yeah,
you-
the focus is a little bit off.
yeah.
Yeah.
Remember those with the IDE hard drives?
I hated them because
Yeah.
always like one pin was
Yeah.
bent or split, and
Or DVD writers, they also use this kind of power.
yeah.
Later on, you also saw some SATA ones, but mostly you had this one.
Some overclocking boards still have this for the VGA for
Yeah,
extra power.
for the VGA. Yeah.
For the PCI Express bus plane.
Yeah, but not lately, I think.
Oh, maybe next
Or
year
maybe.
again.
I really don't know. Yeah.
Maybe next year again. Hint, hint, hint.
And then the rest of them are for the graphic card. So there's also cables that goes with an 8-pin inside the power supply, and then there's like two with a loop through to two 8 pins. So that also works, but remember, if you have a high power graphics card like a 3090, it's better to have like 3 separate cables, because then the cables don't need that much load, because this load of this cable is fed through one single 8 pin wire or 8 wire cable. So it can work, and if you look at the 3090, I also did some testing.
We're going to do some benchmarking later on as well, right?
Yeah, but I just want to show which power connector draws the most power. The one closest to the I/O panel draws the most power. Then the second one almost draws the same power, and this one draws much less power. So
and is this always in these kind of designs, or is this MSI only?
Yeah, it depends. So it depends per card. So if you have a RDX 3090 Gaming X Trio, then it's true, and yeah.
Because I know in Lightning we had a different kind of design on purpose.
But the 2080 Ti Gaming X Trio had the same, same configuration.
Yeah.
So yes, it has 3 8 pins, but this one could have been like a 4 pin or 6 pin. Yeah, 4 pin is not used in graphic card, but the power here is I only measured like up to 6 amps, so that's up to 70 watts.
A lot of questions. Is it coming like a 1000 watt PSU maybe with RGB? Well, don't know. Maybe next year we will see. But most people don't really need this. Okay, they need maybe the RGB stuff, but not the 1000 watt. Do you have any temperature monitoring tools like Corsair? I'm not sure if Corsair, the AIX, I think it is, or something like that. I don't think they have. I'm not sure if they have temperature monitoring, but they have like a wattage sorry, Ruud, I will put you here. Wattage monitoring. Do you know if they also have temperature monitoring?
I don't know, but this one is not with.
No. This is without. This is just a power supply. Dutch, yes, we're from Holland, based, located in Holland. No secret. These power supplies are already available in most markets like Europe and APAC, Asia. USA will be next week. No, currently no SFX power supplies planned. Is it too costly to make a low watt titanium PSU like 500, 700 watt? Yes, because I was talking with one of our engineers, said, okay, we have 650, 750, 850, and I said, well, why don't we have 450 and 550? Because I think that's also a market for that. And he said, well, we want to focus at gold, because gold is a very important standard based on efficiency. And if you're going to produce like a 550 gold, it's the same cost like a 650 gold. So he says then the market for a 550 gold, you have them. I see them, not in all markets, but they are there from several brands. And if you're talking about titanium in that wattage, indeed. I mean, the efficiency, the cost to produce the efficiency on lower wattage is higher. So basically, it's less interesting for everybody.
Yeah. The efficiency is the real challenge. That's why they changed the power supply spec, or at least how they are designed these days. Just focus purely on efficiency, and they're stretching it already. So titanium is really putting some challenges on, because the 10% requirement also need to be very efficient. So
I see.
Price premium will be there.
Yeah, so it's possible, but it comes at a cost.
Yeah, exactly. Yeah.
Yeah, and what about the 12-volt motherboards and power supplies?
Yeah, I saw on Linus Tech Tips that Dell was already using them.
Yeah.
And they were using the Platinum, so the A+ Platinum. And well, that's kind of smart, because if you only need to output 12 volt, then you don't have to worry about the 3.3 and the 5 volt card anymore. So this inefficiency is gone. So what that makes is that this little card will be put on the motherboard,
Yeah, so basically there is a new standard. Intel is pushing this. We also don't know if Intel can use, if AMD can use this in the future. And it's all to improve the efficiency of motherboards. So basically the power supply is a 12 volt power supply. And yeah, I was discussing with Ruud and he said, yeah, well, basically they put a 5 volt then to the main board. So
Yeah.
the power supply will be very efficient.
But yeah, they will lose a lot of power on the motherboard, but the motherboard is not in the efficiency certification, so
Yeah.
they can do whatever they want. So if they have a lousier power conversion on the motherboard, then the whole system will be less efficient than if the power conversion was done in an efficient power supply. So
Sorry, Duo Maxwell. Last week we played Assassin's Creed Valhalla. Probably that's why it says. Well, anyway, we're giving away some codes today. Yeah.
and I have a chair.
Yeah, we're not giving that one
Oh,
away.
no, okay.
Yeah, 12 volt power supply is too early to talk about. I don't know any concrete plan. This is also a very niche market. At this moment, I already see, like what Ruud said, OEMs are using it. Was Dell, you said?
Yeah, I think it was Dell.
Yeah, and for them, it's very easy to adapt it because they have large scale. They have everything is tailor-made for them. So they say, I want a 12 volt PSU, but also I want a 12 volt mainboard. These all specs. I know several people who work at those big OEMs, and it's.
But if you make a system like that and it breaks down after warranty, it's very hard to find a replacement part for it. So
you are stuck with, in this case, Dell.
Yeah, and then you have to call Dell and ask them what does a power supply from you cost?
Yeah.
And then you will be amazed.
And then you will be surprised.
Yes, exactly.
Yeah, that's always with new technology because first you need adaptation and maybe even a second-hand market before you can have a service market. Otherwise, you always.
Yeah.
Yeah.
Yeah. But yeah, I think it could be good. But yeah, there's also voltages that have been dropped from motherboards, like I think the minus 12 volt is not used anymore, and minus 5 was also dropped in most power supplies.
Yeah.
So yeah.
Eagle Claw is asking for our big Navi cards. I think we already showed them 2-3 weeks ago. Not last week, the week before that maybe. And yeah, big Navi, it's a big shortage. So we even don't have any samples. With the 3080 launch, that was the first one, 3080, 3090, 3070. We already had like 3-4 samples here, but Big Navi, we even don't have samples here in our office, let's say like that. Of course, we have them in Taiwan. Let me see. Yeah, maybe let's talk a little bit about this, Ruud. So these are 3 power supplies, and I see a lot of OCP, OVP, OPP.
Yeah, the C
I know the P is protection.
Yeah, and the O is for over.
Okay.
So the C is for current, the V is for voltage.
So it's over current protection, over voltage protection,
over power,
over power protection,
over thermal,
thermal protection,
short circuit protection,
okay,
and under voltage protection.
Okay.
Yeah.
So basically,
if you draw so much current that your voltage cannot keep up until a certain standard for 12 volts, and it will drop below it, then it will shut itself off. That's the under voltage protection. And the overcurrent protection is the one you might face, or the short circuit protection. That's something that's really helpful if something goes wrong. You know.
You will not damage your components.
Yeah, damage your components or set the whole thing on fire. Yeah.
I like that fire. Active PFC, that is the order switching between 115 to 30, right?
No, the power factor correction. That's the one to draw a clean power from the mains. So that's also improving efficiency and not throwing any power back and forth.
I thought it was different.
No, the auto switching is also in that circuit. But
okay, so it's related to that.
It's one chip that does it all. So yeah.
Yeah.
But need some chokes and also some
okay,
switches.
So I'm going to do a giveaway. You want to pronounce the winner?
Oh, sure.
You didn't see it yet.
No.
Let me see. One moment. So, wow, this was easy. Can you pronounce this one?
Yeah, that's Daniel.
Yeah.
Congratulations.
Daniel. Congratulations. You get should I go somewhere? No, you get a Assassin's Creed Valhalla code. Valhalla, we learned last week with Ubisoft. We will send to you in the coming days by email. If you want to participate, I believe our chat bot is spamming Twitch and YouTube. If not, let me know in the chat. So if you're on Twitch or Facebook, if you're on Twitter or Facebook, please go to Twitch or YouTube. Then you see the link. Or you can go to msi.com/2/insider to participate in the giveaway, and later we'll give away some more codes. I'm going to do a second one. We talk too much. Let me see. System drawing. Yeah, Ruud, is also nice for you to pronounce.
Yeah, have a great day.
So have a great day.
That's a nice nickname.
Congratulations. Yeah, that's a nice nickname indeed. Congratulations. Again, same story. By email you get a Assassin's Creed Valhalla game code. I'm going back to the chat. So Ruud, now we're going to talk a little bit about all the components we have on a PC, a gaming PC.
Yeah.
And we're going to do some benchmarking. We have on the right corner, we have this power meter.
Yeah.
Was a lot of work to get this working because normally we use like a power meter you put in and there's a display on it, but this is like a digital one. And to get the readout displayed here. Anyway, we did some magic. It works.
Yeah.
We will find you. I mean, we never did this in the past. We always talk about benchmarking, and then people ask about power draw, and we're like, yeah, sorry, we forgot about that. So now we found this out, and in future live streams we will try to do this more. And we need to fine tune some other things. Anyway, let's talk a little bit about what components are using, because if you have a PC. So Ruud, maybe tell me first about what you have over there, the system.
This system is with a Ryzen 5 2600X. So that's one of the earlier Ryzens.
Maybe do the detailed cam?
Yeah, sure.
This is going to get messy.
Yeah. So the Ryzen 5 is underneath this cooler. And then we have a GTX 1060 card. It's an Aero ITX, a smaller card.
So 1060, that's good enough for 1080p gaming 60 FPS?
With most games, yes.
Yeah.
But if you have more recent titles, then you want to upgrade. Of course,
yeah,
right?
indeed. Or if you want to go to 4K or some higher...
a 1440p, then definitely need more power.
No, a lot of people are asking about RAM. No, we don't have any plans to make RAM.
Okay.
Not yet, but this can change tomorrow. Will your 6800 XT come out on the 20th of November? Sorry, cannot comment about that. That's NDA. Yeah, I mean, the finished card, which is announced today, I think we're already shipping. Maybe already in the stores. To be honest, I don't know. But our own design, our custom design, I cannot talk about which date. But you will find out soon. So.
Okay.
So back to the topic. Because.
Yeah, basically the large consumers in your system, and mostly we were talking about gaming systems, is of course the graphic card on number one spot and CPU on the second. Also depends on what kind of combination you're running.
Yeah.
But if you want high resolution or high details, high refresh rates, then usually the graphic card will draw the most power. And that can go up to 360 watts in this table, but yeah, the one we're using is already
we actually found out it can be much more.
Yeah, and the power limit is for if you have an MSI graphic card, you can just go to the website. And
well, I can show that. Maybe you let me see.
Example,
Is this still live, your system?
Yeah, that's live. Yeah.
Maybe you can do a benchmark. I don't see your mouse moving.
No, I didn't move it yet.
Okay, okay. Yeah, so maybe
Is he
maybe you
moving
can
now?
already do some benchmark to show people the power
Oh yeah,
draw.
sure.
Then I'm going to
So this is a Ryzen 5, and you can load it up with the CPU load, and we're using Cinebench for this.
which VGA card should I open? Which one do you want to with power limits, etc.
Let's use the RTX 3090 Gaming X30. That's the one we're going to be using when
Okay.
we upgrade this system. That's the demo. So now we're running Cinebench, so the power is shooting up to 190 watts from the wall outlet, and most of that power will be consumed by the CPU, of course, because this is a CPU only load and benchmark. I think we can also show you how much power the CPU is drawing if I'm quick enough. So package power is around 115 watts. So from the 195 watts power going into the system, 150 watt will end up in the CPU. So this is, the rest is just the motherboard, the power circuit on the motherboard, the SSD, and the graphic card will consume a little bit because it's only 2D. It will not consume much, like maybe 20 watts or something max.
Ruud,
10,
on 3090 gaming, I don't see the power limits. Or where did they put them?
They should be on the specification.
No.
I checked yesterday and it was still there. So
Maybe
maybe
I'm
they changed
blind.
the website.
One moment. Well, let's wait until this benchmark's finished, or not?
Oh yeah, sure, yeah. The power will not fluctuate that much because all of its 6 cores or 12 threads are running, and once it's done and threads have no job anymore, then the power will drop, or if the job is finished completely, the power will go back to idle.
So this is CPU benchmark, right?
This is only CPU. So now we see what kind of power a Ryzen 5 from a few years old will draw, and for a new
2800.
this is a 2600.
Oh,
but
26, sorry.
Yeah, the
Yeah.
3600 and the 5600 don't draw much more power than that, so they
Yeah.
just have much more performance. So if I just click this away, you'll see it will be 2900 points. Not bad, but yeah, it can always be better, but that will come at a cost, and especially a power cost. Of course, we can also game on this system. That's
Should I write down the values, or you remember them?
yeah, you can write them down. You can also watch them back if people are interested. We can do like Shadow of the Tomb Raider. And then also the GPU will draw more power. Of course, in Shadow of the Tomb Raider, I need to set the settings a bit lower, so you'll still have some FPS.
So,
With the 3090, you can put it on max if you're on 1080p. But with the 1060, you still have to drop a little bit to get over the 60 FPS mark. Maybe I've set the settings to relax now, but we'll just run a benchmark to see what kind of power draw we're going to get. And I think most people will be running systems very similar to this and running like a power supply that would be 500 watts or close to it.
yeah, same. I also have a 550 at home.
Yeah, for example, yeah.
And when I took the 3090 to home to play some nice games, I needed the extra power supply.
Yeah, we'll show you how much you will need. So Shadow of the Tomb Raider is already very power hungry in the menu.
So the power usage depends of difference per game.
Yeah. Also in this overlay, you will also see the power. The green bar or the green graph is from the GPU, and the blue one, that's the AMD CPU. It's the core and the SoC power combined. I get that power from HW Info 64 because that power is not included in Afterburner yet for the 5950X yet.
So I see about 250 watt on the meter, and
Yep.
the GPU is using 90 watt, and the CPU is about 60 watt. So it's 150 watt.
Yeah, the GPU is running close to 100, yeah.
Yeah.
And I think the CPU fluctuates the most.
Yeah, I see 30, but I
yeah.
also see 90.
Yeah. And the higher the FPS, the more the CPU will be working, and also the power draw will go higher.
Okay.
The power draw on a full load for this CPU was around 115 watts. So yeah, so it's not maxed out at any time in this game. But if you would put a 3090 next to it, then the CPU will be
Is that the
struggling to
GPU
keep up.
power from the motherboard? No, that's the GPU power from the power supply and the motherboard, right? That's the complete power the CPU is using.
Well, which one you mean?
The green one.
The green one is the GPU only.
So that's not
Well,
only...
that's the full graphic card. So,
Yeah.
yeah. So the power comes from the PCI Express connector and a 6-pin power from the power supply.
Yes, we're also going to test 3090, and
Yes,
you will
yes,
be
yes.
surprised
But
or amazed maybe.
As you can see here, if you're a gamer, and I think Shadow of the Tomb Raider puts enough strain on this system, we're looking at like 250 watts, close enough. So with this kind of configuration, then a 420 watt power supply would be more than sufficient, I would say. But most people bought 500 or more, and that's not really bad, but it might not be the most efficient one. So maybe the power supply would be better in the 500 watt range than in the 420 watt range, also depending on the quality and
Yeah, that's also something you
yeah.
need a quality power supply. But nowadays
Yeah.
with the labels like gold and platinum, titanium,
Yeah.
you know what you're buying based on efficiency. In the past
Yeah.
you didn't have this.
Yeah, without the label, then you don't really know what you get. And usually, if the power supply just weighs almost nothing, then steer away. That's not something you want. And the certification does help. It means people have really invested in the efficiency, and you can only do that with good parts. Doesn't mean it's the best or longest lasting power supply, because not many people test it that long. So this is what you get. 76 FPS on average, and as you can see, it's fully GPU bound. So, you don't see my cursor. Anyway, this is what kind of power draw you will get during a gaming on this system.
Yeah. Let me answer some questions. Let me see.
We could do another one with an extreme stress test.
Any ETA on UniFi X boards? Sorry, no, I don't have. How many CPUs burned in China? How many GPUs burned in China? Don't know about that. Oh, or factory. That was no production line was damaged. No people hurt. Yeah, Kus on Kus on Twitch is saying calculate my PSU on Google. Search that. There are calculators. You checked several of them, right?
Yeah, I checked several of them. I forgot.
Because some are correct and some are incorrect.
No, of course there are estimates. So in some you can select anything. So including the fans or whatever. One of the one I was impressed by was the PC part picker. I think many people know that. And you can actually pick.
You send them by email to me? Yeah, right?
Yeah.
Can I show that data or is that NDA?
No. It's the configuration we have here, almost completely.
Yeah, but also your spreadsheet.
Oh yeah, you can show that, no problem. There's no really any secrets there. It's just some test data I put together.
Always asking.
Preparing.
One moment.
But there are several power supply calculators on the web on websites. PC Part Picker also, if you assemble or if you plan to buy a system and you pick the parts, it will just calculate the power for you, and then you will know what kind of power supply to buy.
I'm not sure if I can share this like this.
Yeah, there should be a link in the first. I think the bottom link is to the PC Part Picker system. That one, yeah. Click that one. And in the right top corner, there should be like a power. Maybe I don't know if you can zoom in. It's very small for me to read.
One moment. You do your benchmark.
Yeah, at the moment I'm stress testing with AIDA. There's a stability test inside, and it's loading the CPU to the fullest memory and also the graphic card. And then you will see power draws. This is really absolute maximum, I would say. It's almost very, yeah, it's the same as if you do like a Prime 95 and a Furmark together. And this is running up to 280 watts, so yeah.
Stop scalping.
I'm not scalping.
No, somebody said that. I think he's referring to the US.
Oh, yeah. Okay.
Still angry.
Of course, yes. But you had the PC Part Picker?
Oh, yeah. Remove this cookie.
But we can safely say that this system will not run any over 300 watts. So. But there's one note.
I'm on PC Part Picker, Ruud.
Yeah, in the blue part, I think there's a wattage there, right?
Yes, 594 watt.
594 watt. That's the system we're gonna convert this system to. I use the X570 Unify for this because it accepts the older Ryzen 2000 series as well as the 5000 series. So I can show you an older type system to a really new high-end system and see what the difference is in power draw. So 590 is the estimate from PC Part Picker.
Okay, and you will change our system, the one we have here.
I think we can shut down the AIDA, so we haven't seen it
one moment.
Go over to 280, 290. Now it's at 275. It's jumping up and down a little bit. Mostly that's because of the graphics power. Usually graphics loads are not really a consistent power, but more jumping up and down, so yeah.
You also told me that a lot of people look to benchmarking, what kind of power supply they need, but it's better to look at real life situations.
Yeah, I think most PSU calculators on the web, they just use the maximum power and they take the TDP from a CPU and the TDP or the power limit of a graphic card, and then starts adding up all those maximum limits. But if you look at what's realistic, of course you want to be prepared for the worst case scenario. So if the CPU and the GPU would draw maximum power at the same time, then the power supply should still be up to the task. But that situation almost never happens unless you do like stress testing that artificially loads CPU and GPU to the maximum.
Yeah, so and I was also, I said like, okay, I have a 750 watt power supply, it's 80 plus efficient, so I was deducting that, but you basically said, no, the rating is the efficiency.
Yeah, so yeah, the power supply can do 750 watts on the DC side.
Yeah, so
our wall meter, the one that shows 3 watts now, because I turn it off.
So who's stealing the 5 watts? If it's off?
The power supply. There's still 5 volt standby voltage, which still powers the some parts of the motherboard. Also, if you want to have power on features like wake on LAN and stuff, that means the LAN chip needs to be active. You can turn that off as well in the BIOS. So if you don't want to do that, then it
So
will save you
this is
half a watt or
basically the
something.
power you use for standby.
Yeah, yeah. It's kind of a standby. Yeah.
Okay, interesting.
I will do the switch, and
Yeah,
I will convert the system.
I'm going to show a little bit about.
Yeah.
Well, yeah. You're maybe I will put you behind
Oh yeah.
my slides
I'm
like
cut
this.
off a little bit. That's,
Yeah.
that's okay. That's okay.
This is also what I found quite interesting because if you
Yeah.
look at TDP, and I'm sure Ruud can talk hours about this. If
No,
you
I'm
look,
not marketing, so
yeah, if
few
you look
minutes,
at TDP, not everything is created equally. For example, the 10600K from Intel is rated 125 watt, but also the 10900K is rated 125 watt. But if you look at the statistics, if you look at the benchmarks, and this is taken from tweakers.net, you see that this is Cinebench. So basically Cinebench is putting 100% load on your CPU.
yeah, on all cores. Yeah.
Yeah, on all cores indeed. It's a multi-threaded benchmark. Then the 10600K is drawing around 100 watts. So 103 in this case, 104 almost, which is like 25% lower, I would say, than the 125 watt rated. And this is a 6-core CPU. If you look at the 10-core CPU, the 10900K, that's 10-core, right, Ruud?
That's 10 core and the same
Yeah.
socket and
Same socket,
same TDP.
but it's
But-
drawing 238 watt.
Yeah, and the main difference is because there's an Intel recommended power limit, but most high-end motherboards, they allow you to run unlimited.
Yes.
And then the turbo goes all the way up to as high as it can, and then it will draw the 238 watts.
And it can probably even draw more if you cool it correctly, because the turbo is limited by the cooling, by thermals.
No, not really. I think if the power limits are off, then also the thermal velocity boost is also unlimited. And that's why it's drawing that kind of power.
Yeah.
If the thermal velocity power is not on, then I think it will draw around 200, 210 watts, something like that.
No difference.
A little bit different. It's also
Yeah.
100 megahertz lower. But there's an even more extreme power draw if you put Prime 95 on or any Linpack kind of stress testing like OCCT. It will go on to I think about 290 watts unlimited. If you don't want that, or
People are saying
your cooling
12.
is not up to it, then set the power limit in the BIOS to a lower value so your cooling can be up to it.
Yeah. Ruud, people say 12-core dummies.
No, the 10900 is still 10 core.
I'm going to Google it.
Yeah, just Google it. ARC Intel. Let's. Did I connect everything? Yep. No cables in the fans. Yeah, a little bit. Also more RGB on this one.
Okay, I'm going to show you what Ruud is doing. So you switch out the system.
Yeah. It's running full fan now because I switched the CPU, so the BIOS will be reset.
10900K ARC. ARC is the Intel database. I'm not sure what it stands for.
I also don't know.
So, whoa, looks out of focus.
It's,
Maybe a little bit small.
Yeah.
I hope I can zoom this. Zoom. Yeah. So, 10900K. And we're talking about a 10-core part. Dummies. Yes, sorry. Let me see how many people in the chat said that. One. Oh, it's only one person. Yeah. So yeah, sorry. Intel is still on 10 cores. Probably 14 plus. Couldn't make 12 cores.
Yeah,
Oh,
they
sorry,
needed to
I will remove my mouse.
to
This is,
raise the power limit to get it boosting higher so that it could compete with the AMD one.
And yeah, I can imagine. I mean, this is really confusing with all the core, the differences, and that's also why I needed to look it up. 11 cores. Hey, CJ. Yeah. close. So, we were talking about the power CPU is drawing.
Yeah.
And yeah, this also has a lot of influence on the motherboard, because sometimes we see some unrealistic tests. They take an entry-level motherboard and they put the most high-end CPU on there. But that's not realistic. Of course, we try to keep this in mind. They can run. We try to prevent, I should say, that they are starting to throttle. But there is always a limit. For example, you cannot overclock them. The boost speeds only go to that high.
Yep.
So you cannot, if you buy a $600 CPU and you only spend like $70 on a mainboard, that's not realistic. Of course, it works, but just basic spec. Let's say like that. Ruud, I'm going to put you in front of this again, like this.
Okay. Yeah. Yeah. I'm setting up the BIOS.
You also see that a lot.
Enabling
that
XMP,
some high-end CPUs are testing on entry-level mainboard, right?
Yeah. We also have, for example, our B460 motherboards. If you put like a 125 watt CPU on it, then the first question will be, what kind of cooler are you using? And depending on the cooler choice you select, then it will set up the power limits. So for like the B460 Tomahawk, that's a more high-end B460, and that can let a 10900 or K or non-K, doesn't really matter. It can run it without power limits, because the power circuit on that board is so good, you can just run it. But if your cooling is not up to it, it will just overheat your CPU, and then it will start thermal throttling instead of power limiting. So then you still don't get the performance. But if you already put a water cooling set on it, then you can raise the power limit without any problem and get extra performance from it. If you want efficiency, then just go with the lower power limits.
Yeah.
I think
So-
we covered that in a B460
Yeah,
live
indeed.
stream.
We went a lot of detail. Here you also have, because there's also a lot of discussion, you have Intel and you have AMD, and they all have their own TDP, which not always compare.
Klopt, that's true, yeah. Klopt, wou ik zeggen.
Can you maybe comment a little bit from the technical perspective about that?
Yeah, Intel is really focusing on what they call base frequency. So their TDP is rated for, if you have a 125 watt 10900K, it will run at a base frequency, I believe it's like 3.7 gigahertz or something. And it will do that when it's at the maximum temperature, and it will consume no more than 125 watts. So that's what they promise. So a 125 watt cooling solution should be enough to keep it running at a maximum temperature and base frequency. So turbo boosts are excluded from that TDP number.
Okay.
So
Do you
any
need to change
tricks-
something in the BIOS in order to go faster?
For high-end motherboards like Z490, all MSI gaming motherboards Z490 automatically have power limits to the maximum. So it's up to you. Make sure your cooling is capable, and if not, you can just always adjust it later. Or if you want more efficiency, then just go ahead and set it to the Intel recommended setting, no problem.
Stop selling your own stuff more expensive on eBay. Yeah, I think that was
that's the
like
same
1 month
one, yeah.
ago, happened one time by accident.
Yeah. Okay. Is the RGB working? Yeah, all right.
Better VRM temperatures. Would a 5950X be feasible at stock for a B550 motherboard? It really depends on what kind of motherboard. So last week, was it last week? No, 2 weeks ago we did a live stream with the 5950X, and we run it on the new B550 Unify motherboard. perfect for that, even with a lot of space for overclocking, but also entry-level boards. Actually, B450 can also run that. No.
B450, no.
No, B450
No. But
cannot, still not.
B550, most motherboards are very capable of running
Yeah.
any AM4 CPU in stock speeds.
That is the point, stock speed. So
Yeah.
it's basically how much do you want for your money? Because if you want stock speeds, as advertised, no problem. If you can cool it correctly, you can get much more performance out of it. Especially with the PBO boost speeds, etc.
Yeah, but precision boost overdrive is the auto overclocking part. Then you can set power limits similar to Intel, and then you can let the turbos also go higher, but also the power consumption will go higher.
So, if any questions, drop them in the chat. I'm going to check if we have another winner. Let me check. Bum, ba-dum, bum. System is slow today. Now, come on. Refresh. Yes, Ruud.
The nickname is A-Teng.
A-Teng,
A-Teng,
congratulations.
yeah,
Sorry?
I don't know how to pronounce it correctly, but A-Teng.
A-Teng.
Yeah.
Anyway, you will see in his mailbox. Congratulations. In the coming days you will get an Assassin's Creed Valhalla game code. Really nice game. If you want to know more about the game, check last week. I'm saying like that, but we will not put the link over there. Last week we had Ubisoft in the live stream. We had a nice chat with them and we benchmarked the game on one of our new monitors. So Ruud, you switched sorry. And if you want to participate in the giveaway, our chatbot in Twitch and YouTube is spamming the link. Otherwise go to msi.com/2/insider.
Can you check if the NDI is working?
Yes, it's working. So
Okay,
again, we're using NDI today, but we don't care about benchmark scores. It's all about power usage.
Yeah, so maxing out the power on this system is what we're trying to find out and see what kind of power supply would fit this kind of configuration.
So what CPU and GPU did you have first?
2600X with a GTX 1060.
And now you did upgrade to?
Ryzen 9 5950X. So that's the highest, most powerful and high performance CPU from AMD on the AM4 socket.
Yeah.
And to a RTX 3090, also the fastest graphics card for gaming at the moment, and also most power hungry.
Yeah, and you didn't change anything like SATA SSDs or RGB.
No, I connected the water cooling, our Core Liquid 360, and I've added also the RGB from the Core Liquid.
That will make a big difference in performance.
Exactly, also for performance, yes.
Yeah.
More frames per second. I should set it to red, I think.
So this is idle power in Windows. I already see 82, so it's a bit higher. It used to be 60 for the previous system.
Yeah, it was also fluctuating, but it's a 16 core instead of a 6 core. So and idle it will also draw a little bit more. Also, the graphic card is a little bit more power hungry. So
a little bit,
just a little bit. And also RGB on it. The other one doesn't have RGB up, but I don't think that's the main difference. 80 watts, for idle, I think that's okay. It's not bad. It can always be lower, of course, but depending on how high or how high-end your SKU is, the idle power draw will go up with the maximum power draw as well. And the motherboard is still the same, memory is still the same, also setup the same memory timings and speed, so no difference there. And Also the SSD is still an M.2. It's a Western Digital SN850. And
Yeah, we also benchmarked that 2 weeks ago, and that was we did it on Unify.
yeah, B550.
We got like crazy speeds.
Yep.
One of the fastest SSDs on the market right now,
Yeah.
I would say.
I'm still using that for testing.
I asked them, I emailed Western Digital, do you want to sample back? I still didn't get an answer, so I will keep quiet that you can
Yeah, okay.
enjoy the
Okay,
speed,
cool.
okay?
Yeah.
For your benchmarks?
I like them.
SN850.
Yeah. First up, want to do maximum power, or do we want to see gaming first?
Maybe first gaming.
First gaming?
Maximum power will be higher, right?
Yeah, if you go for a stress test,
Yeah.
it would be a little bit higher. But it's, it's more, it's an unrealistic load, I would say. I'm running HW Info 64 in the background, so it will report the CPU power draw. And I'm
Can you
using
maybe move the window a little bit?
this one?
Yeah, that you see.
And also use the afterburner, so it will show an overlay in our games. So before we're using Shadow of the Tomb Raider. Of course, this is a much more powerful system, or at least the GPU can do a lot more. So we'll set 1080p with the highest setting. So there's no reason to limit the settings. Even at 1080p, the GPU will not be maxed out. So it will not reach its power limit all the time. So this is not the most extreme power draw you will see. I've tested it before, and the 1440p, highest setting on Tomb Raider showed the highest peaks, and also very high CPU power draw. I also tested Metro Exodus, and the CPU power draw was a little bit lower, but the GPU was loaded constantly, so the power spikes were less, but it was more like a constant power.
So, Ruud,
Yes.
sorry, maybe don't do anything.
Don't do anything.
I see it's using 600 watts,
Yeah, just sitting in the
and
menu.
you're in the menu.
In the menu, yeah.
Why is that?
It's at the moment it's doing 237 frames per second.
Oh, so you get a very smooth menu.
Yeah, very smooth. Yeah, you see, Lara Croft in the background.
I don't see her.
No, she's camouflaged against.
Oh
the
yeah.
backdrop.
Now, yeah, I see her. I
Yeah.
see her. She's behind you.
Yeah. Anyway, we'll just run a benchmark in the game and see what the power does in the real-time power meter. So power is dropping. Now we're in a loading screen. It's about 250 watts, 280, and once it's loading the 3D, then it will go beyond 600. So it's pulling about 626 watts.
Which PSU are you using now?
850.
850.
Yeah.
Okay.
I thought
Yeah,
for this system.
I just want to make sure we don't get any fire here.
No. For 3090, NVIDIA is recommending 750, and I have to agree with that. I mean, 750 is what I would recommend if you don't do any overclocking.
So
Yeah.
basically, this is at this moment one of the fastest game configurations you can get, right? You have
Yeah.
the SN850
Yeah.
Western Digital's PCI Express Gen 4 SSDs.
Yeah.
You please people don't look that it's not smooth, because that's NDI capturing. We
Yeah.
talked about that.
On my screen, it's perfectly smooth, but yeah, the NDI one is limited.
Yeah. So you have
by the
fast SD,
GPU
you have
cycles.
RTX 3090, and we have one of the fastest game CPUs out there currently.
Yeah.
5950X from AMD Sentry.
We see that CPU is fluctuating a lot, so it's
So blue is the CPU,
Yeah,
right?
blue is the CPU, so sometimes
88
you
watt.
see 88 and then you see 137. And I think this CPU is limited to 140 power limit, so you'll never see more than 140, or maybe slightly higher, but then it will bounce back. The GPU, the green one, is pulling around 360 watts. If it would be maxed out, so in a higher resolution, like 1440p or 4K, then it will be maxed out at 370 all the time. So now you still see some fluctuations. This scene is probably less load, as you can see by the frame rate. Then the power of the CPU will be a little bit higher or fluctuating a bit more. But this scene is doing 200 FPS. Then the GPU can do even more, so it can do higher resolution. It's already maxed out in settings, so it cannot do any higher setting. In Metro, I can do a higher setting in 1080p, but for the capture, we chose to keep it at 1080p, also for this monitor. If you go with higher resolution, then also the frames per second will drop, of course, and it also means the CPU power will drop. So I chose to do like maximum setting on 4K, and it drew less power than 1440p because the CPU was doing less at that time. So for the wall power, it was doing a bit less in 4K than in 1440p.
But that would mean that if you go to 1080p,
the CPU will do more, but the GPU will not be maxed out.
And the GPU is more power hungry. So maybe 1080p is again more efficient than 4K.
Defined efficient then?
Less power.
Yeah.
Yeah, you're correct.
Yeah,
Define efficient, that's not a... I mean, that depends what you put in, yeah.
But indeed, it's the GPU, if it's not maxed out, then it will go from 360 to 320. That's dropping 40 watts. The CPU is not dropping 40 watts if it has to do a little bit less work. So,
Nick Old School has a good question, interesting. What would happen to the computer if the PSU had less watts? So if we did this on a 650?
On a 650?
No, okay, 450, 550, whatever.
Yeah, if you do it on a 550, you can see the power outlet is doing 620. So let's say the 550, 500 or 550?
Whatever. I mean, if you first answer the first one, I'm going to ask you about the second one.
Yeah, if the 500 watts...
I want to hear fire, smoke and fire.
No, it will shut itself off because all power supplies have over power protection. That's one of the abbreviations, the OPP. So once that happens, maybe even the overcurrent protection will kick in first, depending on how you connect it. Also, most 450, 500, 550 watt power supplies don't have 3 8-pin power cables for a graphics card like a 3090. So
yeah, but some people they can use splitters, right?
Also, yeah, and there's also 3090s with less power connectors. If you choose our Ventus, then you only need 2 8-pins. So maybe you can connect that. Not sure if that's wise, but
so Dimitri is saying I vote for a blue screen.
Actually, no. If the power supply says it's going to draw more power than I can handle, it will shut itself off.
So really like
a hard shut off. Yeah.
Not like how I shut down.
Very similar. Yes.
Oh, so
pulling the cord. Yeah.
So okay. So it will not send a how do you say that? Shut down signal to Windows.
No. No alarm. Just turn it off. Yeah.
Okay.
Just prevent fire. That's main priority. Yeah.
And you talk about OCP and then whatever OPP, I know whatever everything P. Anyway, can anything get damaged by that? I mean, will it damage components?
If your power supply is not quick enough to respond, it might damage the power supply. I think mostly the power supply will be the one that's in danger.
And he saves himself first and he doesn't care about the rest.
Yeah, if he says, okay, this is too much and protections are there to protect itself, but also the rest of the system and also the environment, then it will just shut off. And usually you need to pull the power cord out and let it cool down for a minute before you can try again.
Okay, so I don't need to push it like a reset button to remove this protection limit.
No. There are some power supplies units with a self-test thing, but don't really know what that does.
Yeah.
Doesn't always work well. One thing also interesting to show is at the moment we're in just in a menu, it's drawing around 610 watts or so. It's doing like 289 FPS at the moment. The easiest save for power is just turn VSync on, or any frame cap. So if your monitor is capped at 144 hertz, then a frame cap of 144 would already lower the power consumption.
So
and
you
now we're
just
doing 238 watt in the same menu.
just with one click in the
Yeah.
menu.
Yeah, this monitor is 60 FPS, I think. So yeah,
Some
Is
games also have this option, like in the
But set
they have
up
a
at 60
they have an
FPS,
FPS limit in the menu, and they have
Yeah.
a FPS limit in the game. Basically, you
Yeah.
play the game, you everything gets hot, and then
Yeah.
during the rounds, when you're in the menus or in the lobby,
Yeah.
it will cool down the system because it's limited its FPS.
yeah. Of course, if I do a benchmark now, then the maximum FPS will always be 60. So. Yeah.
Okay, but what will do that for power?
Oh yeah, we can try. I think it will stay at the same limit, yeah, more or less. No, it will.
Let
be
me.
more.
I see a lot of questions again.
We'll do it. We'll do it. What was the highest we saw in the first run? I think about 620. Was that a bit of the max?
Yeah, 600 plus.
Yeah.
Pricing power supplies. Let me show that. We already talked about it like 2 hours ago, 3 hours ago. These are the pricing. USD without VAT, that's handled by all the states, and Euro including, I think, 20% VAT. And this is just MSRP pricing. Price can differ per country, per region, per shop, basically. And yeah, we have a Valhalla promotion, so if you purchase one, you also get a game, but you can win them today as well. Not the power supplies, the game. And we have 10 years warranty. So that answers your, let me go back to Ruud.
Yeah.
Okay.
It's still running the same benchmark with the VSync on. So the frames are kept at 60 FPS. And now it's doing just under 300 watts.
I tried retweeting for the giveaway. Sorry, throwaway accounts are not allowed. Sorry, yeah, we enabled that question of that option. It looked like a smart thing to do. I don't know what it means, but maybe you have a throwaway account. Are you trolling sometimes on Twitter? Oh, so many questions. It's the short burst of power consumption spikes you should be worried about. Can we
That's
also
true,
show that?
Yeah. Not with our power meters, no.
But okay, I have some info about that, right?
Yeah, should be. What we see here, the power meter, and also any power meter you can buy in the
Stores?
yeah in a hardware store, I would say. Those things are just rolling averages, so it cannot really pick up the spikes that a scope would be able to detect.
Yeah.
I think Igor's lab is one of the reviewers who always dives into the power consumption.
Yeah,
of
he made his
graphic
own
cards.
power
Yeah.
supply.
Yeah, and
split.
he invested a lot in measuring that stuff. Also zooming in and seeing what kind of short spikes there will be into the microseconds and stuff like that.
Yeah.
And then you will see really extremes. And some loads, especially gaming loads, will jump all over the place. And,
So-
those spikes also need to be buffered, but it depends on how short those spikes are, because most high-end power supplies have enough capacitors to handle that kind of spikes. But indeed, the power limit of the graphics card is not it's not a fixed value. It's not that it will never go beyond that power. So there should always be some headroom in your power supply. So if we had 620 power with the VSync off, then don't go buy a 650, because that's still too tight. It will not buffer the spikes that the graphics card will pull.
So what did we see now? 60 FPS.
Yeah, so
and 230 watt.
no, it was doing 280, I think.
Oh yeah,
max,
sorry, I was checking the chat.
Staying below the 300, so we saved a cool 300 watts. So that,
But from how many FPS did we go to 60? From 200, right? Sometimes.
yeah, I'm not sure what we did. I didn't pay attention.
Yeah,
To be honest.
we had a lot of FPS.
Yeah, and of course this scenario is not the one you probably use a 3090 for. So
No.
1000, yeah, 80p.
But just to
is-
show
yeah.
what FPS, what kind of influence it has on the power, and especially in a menu like this, it's VSync, switching on VSync is cost-saving feature, but you also can cool down your system.
Yeah.
Let's talk a little bit about GPU power usage. So this is from Guru 3D.
Yeah.
Yeah, sorry, we just got it like half hour before we started the live stream, so I didn't include a logo. Anyway, Guru3D.com. This is the peak gaming power consumption in wattage, and we also included, they also included the the 6800 XT in there, which is great, which is about 300 watts. So the new GPUs, if you talk about the 3080, 3070, 3090, 6800 XT, 6800, they're using a lot of power. I mean, you talk about 300 watt for a GPU. That's like 300 watt plus for a GPU. And the plus part, Ruud will explain. And yeah, that's really a lot. But you also get a lot of performance back for that. So this is what from Igor's lab, what Ruud was talking about.
Yeah.
Can you maybe explain this? Because it looks technical, but
Yeah. It's a power measurement running, I think it's Witcher, the Witcher 3. And it measures the power on the PCI Express, so that's the red-orange line. And then you also see the blue line, that's the power coming in with the power cables in the 8-pin, or this is the Founders Edition, so that's using the 12-pin power.
Mm-hmm.
And you see all those spikes, and the white one is just those two combined, so that's the total power. The Founders Edition measured here, it has a power limit of 350 watts, but you also see spikes that go well beyond that. So
450 for...
Yeah, close to 5. And in that same article from Igor's lab, there's also a zoomed in. So what I mean by zoomed in is the window is shorter, so it's just zooming in on a shorter time. So you will see the spikes even higher than this. This is already compressed because you collect so many data and it doesn't really fit the chart. But those kind of spikes can make your power supply shut off if the overcurrent protection will kick in, or the overpower protection, more or less the same. So if that happens, then it's time to buy a higher capacity power supply.
Yeah.
So you need to take into account that the power limit of a graphic card is something the GPU will try to achieve. So if you give it enough load, high enough resolution with a graphical demanding game, then it will go up to that power limit all the time.
So you talk about the power limits. I searched the product page before. Let me...
Yeah, I can do that here too.
Okay, yeah, maybe you do that. Because I couldn't find it here.
Yeah, I checked yesterday. It was still there.
Well, I have the 3090 Gaming X3O 24G and I cannot find power limit. I can see power consumption.
Yeah, that's the same. Yeah.
Oh, that's the same. Okay, yeah, that's
you already
370.
found it. Yeah, okay.
Hey, can you maybe click on the big Navi card?
Yeah.
I saw some people asking about it.
Okay, let's click this one and see specification. If the
Well, maybe the picture. Are you
Is
going
that
to
power
show?
limit?
Are
Yeah,
you going to
300
show
watts,
it? They
see?
asked us. Okay, so that's 300 watt power limit.
Yeah. I'm zoomed in quite a bit on this system.
Yeah,
so
yeah. Okay, so now we showed it.
Yeah.
Next.
Okay.
Well, it's on our product page, so you can go there.
Yeah.
People also asked me, are you going to do a live stream about this? Yes, we want to, but we currently don't have samples, and we're waiting for that. And we are going to do a live stream about our own custom cards. And at this moment, we're not allowed to run benchmarks on them. That moment is still NDA. I believe maybe they announced it today, so I don't know. I cannot comment about that, but we are going to try to do a live stream about that. But no promise, because without samples, yeah, we can talk. I mean, we love to talk, but I'd rather have samples to bench, to break, to play with. Okay, yes. So this is the power limit. So
Yep.
what is NVIDIA saying for this 3090?
The 3090 Founders Edition has a 350 watt limit.
And what is the TDP? 320, right?
No, 350.
Oh, that's
But the
no,
3090
sorry.
is 350 and the
Of the
3080
reference
is
card.
320. The 3080 is 320.
Okay, yeah, sorry, yeah,
So
I'm
you're
confused.
mixing
You're
up
right.
those two, I think.
Okay, so
Uh,
this 350.
350, but this is a Gaming X, so it's overclocked.
Yeah.
And we also gave it a 370 watt power limit because the cooling is so good. So
Yeah.
we can easily do that. And the maximum power limit is 380. That's not really much, but there's a little bit to play with if you're overclocking.
Yeah. So I
Doesn't
also
help
see
that much,
cards on the market which can do 450.
Yeah, I saw them too. Yeah.
So
And
this basically means that
I'm not sure if it can achieve 450 all the time because I don't think there's enough load on most games to do that. Maybe an 8K, I don't know. I haven't tested that one yet.
But
buy
basically
a 8K
it will try
monitor.
to achieve that goal. I mean, the new architecture
Yeah.
of cards, and if you look at the RTX 30 series, their turbo, basically their architecture is so optimized that turbo will always try to achieve the best,
Yeah.
the highest clock, if the
Yeah.
cooling is correct.
Yeah.
So two limited factors, cooling and power.
Yeah. So most of the time it's power limited. So it will just draw 370 watts all the time if the resolution and the load is so high that the GPU needs to max out the work. And
Yeah.
that it will try to pull from your power supply. So you need to take that into account, plus the extra spike. So you need to leave some headroom for the spikes, and this is just an average. So what we saw in the Igor's Labs review,
I can
those
go there
spikes
now.
are maybe hard to predict how high those spikes will go, and also depending on how long those spikes will endure, and depending also on the quality of your power supply. So there's a lot of ifs there. So just leave some headroom, and then you can calculate a little bit or estimate a little bit what kind of power supply
Yeah.
you would need.
The problem what I see in the RTX 30 with those high TDPs, it does not translate to performance that well.
No, but the power is there.
Yeah.
I mean, the power consumption is there. So
Yeah, so basically you overclock a little bit, the power goes up a lot, and you get some FPS back, like 3 to 5% depending on the overclock.
nah, yeah,
But basically, if you're running, for example, 4K, that's only a few FPS.
yeah.
So yeah, then I mean, is it worth overclocking, that much, and especially with the power draw? I don't know tricks to.
I think for the ones who are doing world records or LN2
Sure,
overclocking,
world records, yes.
yeah, then power is not really important to them. But if you're a gamer, then I don't really think overclocking will bring you much. So
Yeah.
then
And then it's
even
better-
a non-X or non-OC version would do just fine.
Yeah. Yeah, because that's really, I mean, if you have like a 450 watt TDP, and I saw somebody, they released extra BIOS to achieve higher power limits. But if you're normal user, normal gamer, you don't need it, right? It will
No.
only draw extra power, and you have maybe a few FPS benefit from it.
Yeah, I did a test on this one as well, and I just lowered the power limit a little bit.
Okay, so maybe
Now
you
we
can
can
do some
demo
tests
that.
with power limits.
I can demo it with the Afterburner.
No smoke, no fire, please.
No. Oh, sorry, double.
MD Computing, I think the Valhalla chair is cool. Yeah, we gave away one last week.
If we limit the power, to do it correctly or do it more efficiently, I would say, let's go with 80%, right? Or 75, maybe that's nice. I don't know. I don't remember what I did before. So 75%. And I unlocked, the lock between temperature and power limit is disabled. So the temperature limit is the same as before. The cooling is more than capable of cooling this GPU. And if I apply that, then I only limited the power. So the clocks will drop, of course. But if you want to do it perfectly, you would just select like a voltage frequency curve. And what you can do with that is basically undervolt it a little bit and get more efficiency out of it. But it will require a lot of time to fine tune.
Yeah, that was one of the ideas you wanted to do today, but you said I need to go
then
home.
we need to postpone to a couple of weeks. So let's not do that. So for this benchmark, I will be running Metro Exodus, as it puts more load in the extreme setting, preset, than the Shadow of the Tomb Raider. The Shadow of the Tomb Raider shows more CPU load and fluctuations, and the Metro Exodus maxes out the GPU more with the extreme, because it's also running the scaling mode at 200%. But let's see what the results will be with a limited power limit. So now we're reducing power, and we see we can keep it around the 500 watts from the wall, give or take.
That's 1%.
And the FPS seems decent enough on this.
So 1080p.
1080p extreme setting.
But you said 200% or not?
Now the extreme setting is scaling to 200%.
So actually it's 4040p.
Yeah.
Hey,
You can see
your,
the green.
your power supply is on fire.
Oh really? Oh no, that's the image. Yeah. Now the graphic power, if unlimited, then it will run close to between 360 and 370 watts in most scenes of this benchmark. Now it's running up around 275 to 280 watts to 85.
And what is the FPS difference?
That's what we're gonna find out.
Okay.
Yeah.
Yeah, sorry.
Yeah.
What about Crysis Remaster? Can you run it? No, we don't have it. Do you, Ruud?
No.
No.
Not yet. No. Can it run Crysis? Yeah, that's the classic question. Yeah. This scene is the most intense, and when it goes outdoors, then usually the FPS will drop.
Because you have a lot of things in the...
Yeah, I think so, yeah. Then it will show up and it will give you 72 FPS on average. Now let's run it. And it was close to 500 watts on the wall?
Yeah, I would say 500 watt minus or plus 1%.
I'll just reset the settings. So only the power limit goes up to 100, the rest I didn't touch. And let's run it again. So this one was 72, okay, remember that. But it's still in the background, so we can already compare side by side. Now the power should go up over the 500 again. And this is the very simple one, and if you limit the power, it will stay just as stable, so it's not really underclocking yet. It's just limiting the power.
Yeah.
So now the power is up to 540, oh, and it's jumping to 590, 570. So it's a bit fluctuating. It's fluctuating a lot. Now where's my overlay? My overlay is gone. Did it reset my overlay? Why did I do that?
Nah, I don't think so.
I just reset it Afterburner.
Oh.
We shouldn't touch that.
Can I redeem the Assassin's Creed code with a new buy of RTX 3070? Let me check. I don't know if VJ is included in the bundle we talked about. I don't think so. No, I don't think so. So the code we give away, which you can win today, you can just redeem in Uplay. So your question is not really clear. Watch Dogs Legion's benchmark is really demanding.
Yeah, the graphs are gone. I know. Sorry about that.
Yeah, you reset too much.
Yeah, sorry, that was my mistake. I should have just touched the power limit.
Click on the
Didn't
screen,
change.
Ruud.
No.
No. Anyway, power draw is much more.
Yeah, it was still fluctuating a lot, so average frame rate. Something more is definitely wrong.
What did you do?
What did I do? Something's wrong. Something's wrong. Let's hang on. What is going on? I didn't set any VSync, did I? No. This one's still up there. Still saying chart. Okay. Yeah.
Real-time debugging.
Yeah. That's when you do live, right? Whose idea was that? Okay, let's just close this one and retry that. Extreme. Let's try that again. Should I restart the Afterburner? I think we should, yeah. Okay. Double check. Monitoring, yeah, still there. Okay. Okay, let's try that again. There's no VSync here, so let's. Here the shading rate is at 200.
DLSS was on.
Really? Did I turn it on by accident? No overlay.
It was Windows Update. Everybody is having some tips.
Yeah, but the overlay. Oh, there's the overlay. Yeah.
Yeah.
Okay, it's back. Okay, so we're running at a 90 FPS, so no FPS cap going on.
Yeah.
Power is at 600 plus. Now the fluctuations are less, I think.
Yeah, it looks like it.
Yeah. So the average was 72. The scene, which is most intense and the frames will drop, is not the fire, but usually it's the when the camera goes outdoors. Yeah.
Yeah.
It's close to the 80. No, there's a hiccup at 82 seconds. Always happens. So before we were running at 72 FPS average at 500 watts, and now we're, I think, closer to the 600, 610 watts average. So that's 100 watts that you will save, but how much FPS does it cost?
That's the question.
That's the question.
So this is like not really undervolting, but just limiting the power.
Limiting the power, yeah.
So
If
you can
want
do
more,
this even more efficient.
If you want more efficient, then you can play around with the voltage frequency curve.
Yeah.
But like I said, it needs a lot of fine tuning. Now the FPS drops to 47-ish, 50. See, it's dropping a lot, so this will influence the average frame rate. But I'm using the built-in benchmark as it's easy to repeat. So the load should be the same all the time. And the GPU power was 280 and now it was 360. So 78 frames per second versus 72 frames per second.
So that's 5 frames difference for
6,
100
yeah.
watts.
Yeah.
And
6 frames, so that's less than 10%. And yeah, we lost 1/6 of the power, so that's 16% power loss. Or
And also you
Power
need to
not
wonder,
consumed.
I mean, yeah, a lot of people will disagree with me, but you need to wonder if you will see the 6 frames.
yeah,
If you will
Yeah.
notice that during your gameplay. I mean,
yeah,
if it's like 10 or 20 and like if you go below 60, because this is the average. Do you see minimum? Can we check that? So
Yeah,
it's
yeah.
45
45 in 1% lows.
in 100%.
Yeah, and 43
Yeah.
in 1% lows.
So I would say that's a small difference.
Yeah. And the maximum is 143 versus 135. So the
Also
the
not
highest
that
peak
big.
is also dropped a little bit. But yeah, usually it's the minimum frames that will get noticed the easiest.
Yeah,
But this is just one benchmark, so
of course.
but this one can max out the GPU quite a lot on 1080p resolution.
So but basically, if you have a power supply and sometimes it's crashing with a 3090, best to do this.
Oh yeah, sure. This is a way to get it also more efficient. But yeah,
But what
I
about
think-
those peaks we talked about? I mean, if you limited it, those peaks will still be there, but
Yeah.
they will be limited as well.
Yeah, of course, yeah.
Ooh.
I don't have the equipment to show that or
Okay.
to test that, so maybe we can ask Igor to do a retest. I saw also he wrote some articles about undervolting, also using our MSI Afterburner and the voltage frequency curve.
Yeah.
And he also confirmed that it's going to take a lot of time to get it in a perfect window for each and every game and every setting, you know?
Impossible.
Yeah, impossible. So you have some quick and dirty settings.
That's
which
what you
already
did.
gave
That's what you did.
Yeah, they already give you results like this. So
Yeah.
save a lot of power and lose a few frames. But you can get more efficient. So I think overclocking this kind of GPU isn't that worthwhile. But underclocking or undervolting is something that would be the new challenge.
You also have to wonder why NVIDIA did this, you know. They probably took the most efficient performance from the silicon, you know, on the curve.
Yeah.
Because after that, we know it's getting less efficient.
Yeah.
Basically, their architecture makes the boost speeds perfect for whatever you can cool.
Mm-hmm.
But below that, I mean, it's a step which is quite interesting.
Yeah. We also saw it with Navi, with the 5700 XT from AMD. They had very similar results. So the turbo,
Pushing the limits.
the turbos are getting better. That means the turbo is already achieving efficiency and maximum performance at the same time. So manual overclocking. We also see that with the new Ryzen, with the Vermeer. If you do manual overclocking, usually you will set it under the single core load turbo, so you will lose single thread performance and gain a little bit, but less efficient power to performance ratio in all core loads. We can do some more
Well, let
more
me
power? No?
interrupt you a little bit,
Oh, sorry, yeah.
because the next winner is Pierre-Louis Smith. Congratulations. Hey, I pronounced it correctly, right? Yeah.
Yeah.
Congratulations, the coming day you will get a, one moment, I will go here. You will get a Valhalla game code. We're still going to do one more draw, so if you want to join, go to msi.com/do/insider or follow us on YouTube or Twitch. I always need to think about that because there's a bot which spams the URL each like 5 minutes. We go benchmark again. Maybe let's maybe talk a little bit about the cost.
Oh yeah.
Michiel put this all together.
Yeah.
So I mean, yeah, he said if you use your computer 4 hours per day, fully loaded.
Yeah, let's say gaming. I mean,
Yeah, let's say gaming indeed.
Yeah.
You game 4 hours per day with maybe 500 watts. That will be like per year in the US, and we took a price of 0.13 USD. For me, that's quite cheap. That would cost, what did we say, 400 watts, right? No, 500 watts, sorry, 500 watt. That would cost like 95 USD per year, based on electricity cost. In Europe, on average, that will be 131. And in Europe, we took 0.18. Ruud and me were based in Holland, and I think in Holland, Ruud, 0.22, 21?
23, I believe.
Maybe 20. Oh, you have a bad deal.
That could be, yeah, indeed.
No,
it's,
but yeah, like 22, yeah,
Yeah.
indeed. 23 maybe?
There was like a table which lists all the European countries, and most of the Western European countries were on the top side, and the East European countries were on the bottom side. So
Utilities.
the best way to game is Ukraine, I believe.
Okay. Or to mine.
Oh, to mine also, yeah.
Yeah. To mine some
Yeah.
Bitcoin. Anyway, so yeah, so let's say we were talking about 750 watt combined with this 3090, and you have the 5950X. Then yeah, 700 watt for gaming. We saw that.
Yeah,
well,
we
600
saw
maybe.
600 during gaming.
Yeah, let's say 600 watts. So you talk about a gain of, yeah, I think each time is like 25%. Not really. 25 euro added to it. That's
Yeah.
more close.
If you go from 500 to 600, it's 100 watt difference. So
Yeah.
it's 1/5, so it should be 20%.
Yeah. So yeah, how can you calculate this? Michiel also put something together. It's quite easy. You take the wattage, you times the hours, 4 hours in our case. You divide it by 1,000, you get kilowatt per day. You times 365. That's the number of days per year. Then you get kilowatts per year, and that you multiply with the with your local price.
Yeah.
You pay, and then some countries you have like during the day it's more expensive than in the evening.
Yeah.
Like you have 2 meters or a split meter. I don't know how you call it.
Yeah, double meter, yeah.
Double meter, yeah, double. Yeah.
Let's see what kind of maximum power draw we can achieve. So loading the, artificially the CPU and the GPU. Let's go with the AIDA stability test. It's easiest to run all at the same time. You can also use OCCT.
Is the PS5 power supply from MSI? No, for sure not.
The what?
The PS5.
Oh, no. So this is loading.
The fans in our power supply, we talked earlier about that.
It's not doing that much.
We're using a 144 millimeter fan, and it's a fluid dynamic bearing fan. Yeah, they're quite silent. I mean, I'm not going to say it's like this decibel, because it really depends on what kind of test you do. So these numbers, only if you have go to a media website where they compare, because they always use the same test method, then you can compare numbers. Ruud?
Yeah, it's fluctuating still a lot.
So what do you now, is AIDA?
Yeah, this is stability test. So what it tries to do is load the CPU to the maximum and the GPU to the maximum. And what I saw is it's fluctuating between 600 and 660. So not sure why it's doing that fluctuation that much, but it's very similar.
Is AIDA the most intense benchmark for your system?
On AMD, it doesn't really matter that much, because AMD doesn't, let's say AVX doesn't affect AMD that much than Intel. So Intel, when it gets an AVX load like the stress tests are using, usually it's Linpack or some prime number searching like Prime 95, then the units in the Intel will draw so extreme powers if the power is unlimited. With AMD that doesn't happen, so you can throw Prime at it and the power consumption will stay very close to its TDP. So the difference between Cinebench or Blender or OCCT or Prime 95 will all be very similar to the CPU. If you do that on Intel, then the Cinebench will be unlimited power for 10900K will be 220 watts. If you go with Prime 95, it will be 290 watts.
Yeah.
And 290 is far away from 125 watts.
But again,
TDP.
all those watts you add after the, let's say, on top of the standard clock speed, they're not efficient.
No.
Otherwise, the company would already sell the product like that configured.
Yes. So yeah, so power unlimited or the power limit set to off or to maximum is already considered. It's not considered overclocking by Intel, because You're not.
It's
You're
in
just
there.
using the turbos to the maximum.
Yeah.
You're not overclocking or overvolting anything, so they don't see it as overclocking, but it's running out of its recommended spec, I would say. But and power consumption will increase tremendously, and performance will just increase a little bit. So that's what we see at CPUs, but we also see that on GPUs. So yeah, seems to be a trend with ever better getting turbo mechanisms in CPUs and GPUs.
People
But-
say run Furmark for the ultimate test for the PSU.
Yeah,
But
it's,
you say
it's very
on-
same to AIDA. If I do Prime 95 plus Furmark is very similar load to the AIDA stress test.
You have them here?
Not on this system, I think. No, I can download if you want.
Oh, okay.
Yeah, we can do that. Yeah, no problem.
If MSI PSU can survive Furmark plus Prime 95 at the same time, then we're good.
Okay, let's do that.
So bye bye people. I mean, if we see smoke or fire, you know what happens.
Yeah. Okay, Prime 95, download latest one. Yes.
I saw somebody asking something about a laptop. Oh yeah, when is Stealth 15M available in the US? Sorry, I don't know, Michael. US, Michael.
Prime downloading, okay, Furmark. Always need to click twice, yeah.
But it's best to go to us.msi.com. If it appears there, it should be available soon. VSync saves a lot of money.
Yeah, that can,
Yeah,
yeah.
Nick is completely correct.
Yeah. If you don't like VSync, there's also other ways to cap your FPS. Also, the Riva tuner in Afterburner also allows you to do that in most games. But there's other ways as well. Also, some games they have a FPS cap right in the settings.
This is the 850 watt CPU of PSU, right?
Yes, because we're going to do.
Because we had one.
We have one, of course, and we can also do some overclocking and
Yeah.
do Prime 95 and Furmark, right? Let's load it up a little bit more than the default. It's a 3090, so it can do that. Just do GPU stress. Yes, go. Oh, we also have overlay, cool. Then also load up Prime.
So Furmark, for those who don't know, is for the GPU and Prime is for the CPU.
Just stress testing small FFTs. Okay, go. Let's lower this so we can see the
Oh,
overlay.
I'm joking.
I was worried a bit.
I had you already.
Oh,
I hope
cool,
more
yeah.
people in the chat.
Yeah. So the power, it's doing, yeah, it's not fluent because it's gonna take all the GPU power it can get, the Furmark. So the NDI is struggling to output frames, I think. But the power meter is not hooked up to this system, so it's just reporting the power on a different system. And it seems to be very similar to AIDA. AIDA FPU test is stability test is very close to AVX load of Prime, and you will see that also on Intel.
Yeah, so next time we also should take an Intel platform because then we really see
Yeah, you can
more
do more
power.
power on the CPU part. Yeah.
Yeah.
We can do more power on this one as well. I will show you in a minute. We can watch this run, but we can also do more power.
Yeah, more power.
Yeah, more power. Okay,
More
cool.
power.
Yeah, let's do that. You're easily to be convinced. That's good. So.
We actually have a smoke machine here. We can fake
Oh, cool,
the
yeah.
smoke.
Oh no, sorry, not for my wrong one. Ryzen Master.
Okay, so now
So-
you're going to overclock the CPU.
Yes, I'm not gonna do any weird stuff. I'm just gonna use Ryzen Master, and at the moment you will see its OC mode is in default because I just loaded defaults in the
Maximum.
menu, in the BIOS menu, and that will set the total socket power of 142 watts. So that's very similar to the power limit of Intel. Also the electrical design current is 140 amps max, and there's also some sustained current limit. But what we're gonna do is we're gonna overclock. I have to create a profile and then choose precision boost overdrive and
Where are
or
you?
auto overclocking. Let's do that.
Where is your mouse?
Oh, my mouse not visible. Oh, sorry, that's my bad. Capture settings. Mouse
I think the
button.
NDI stopped.
No. Did it?
Yeah, I think NDI stopped. Let me check that.
Yeah, stopped.
La, la, la. I'm going to switch it to.
Maybe because of the Furmark.
Yeah, it could. Oh, you're still running it? No, not right now.
No. The Furmark is off.
Oh yeah, that's a problem.
Yeah, it loads up the GPU so much. Yeah.
Okay, so I'm going to switch to this one, and then I'm going to switch 3090, right? Then I'm going to switch to this one.
3090. It's coming back.
Maybe you reboot the. Oh yeah, there it is.
Yeah.
Yeah, we have it
Yeah.
back.
Okay. My cursor.
Hey, but I didn't think about that. We are capturing with NDI, so
There
you-
won't be any CPU or GPU cycles left for NDI because it's all consumed by
can you
Prime.
maybe put the CPU? Yeah, that's GPU priority.
Yeah. No.
Okay,
GPU
just do it. I mean,
Yeah. We will see the power meter anyway, even if NDI stops outputting frames.
yeah. But
Uh,
NDI is what we use for capturing.
Yeah, you can do the precision boost overdrive, which allows you to increase the power limit. Basically.
Can you maybe?
So the power limit goes up to 500 watts. You can also do the auto overclocking, which is precision boost overdrive plus overclocking. So you can also add anywhere between 25 megahertz to 200 megahertz. And then my screen is too big. There should be an
Famous-
apply button here. Oh, there it is. Okay, yeah.
Yeah, we scaled.
Yeah,
we scaled
because
the
of
font.
the 150%
Question: I'm
scaling.
planning to upgrade my
Yeah,
CPU
I
and
need to
memory.
restart,
How do
it
you
says.
find which others are compatible? A good question. If you go to a mainboard manufacturer on the product pages of a motherboard, you can always find which CPU fit in the socket and are tested, and also for memory compatibility. But yeah, most times, I mean, you choose either Intel, AMD, and then you know what platform you're going to run on. Yeah, clarify indeed, Dimitri, sorry. Intel 5 Sitting Gig, improve my stream quality. If you have an NVIDIA card, you can use NVIDIA for capturing. You can also use an external PC or a capture card. Is AMD Smart Access Memory any good? We didn't test it yet. Yeah, we first of all, we don't have a GPU, and we are waiting for a BIOS update. But,
There are
what-
already beta biases online.
Oh, you have beta BIOS. So
Yeah.
what we see, you know, in like 4K, it gives almost nothing, and 1080p, it's like few frames, right?
Yeah, at least the reviews today, the
What
ones
we
we
saw.
had time for to
Yeah.
look at, showed some improvement in the lower resolution settings, but it was not really mind-blowing.
Is it possible to take the motherboard, GPU, and etc. from the MSI Infinity S10 and put it in a bigger case? Yeah, no problem. It's just a regular motherboard.
Yeah.
Uh,
The Infinite S, isn't that the smaller one?
oh yeah, that's the smaller one.
But is that a micro ATX?
Ooh, sorry, I don't know. That's a custom motherboard.
Yeah. Anyway, yeah. But we're back at after rebooting because of the overclocking. It needed to restart. So boost override is 200 megahertz, and power is almost unlimited, or at 500 watts for the CPU. If we reach that, then we need other means of cooling. But we're gonna run it anyway. And let's go with prime and the Furmark, right? I think most people think that's the most extreme test we can do, then let's do that. I'm gonna run Afterburner to see if we can get the overlay running. Maybe also not enough cycles for the overlay. We'll see, we'll see. And so we can overclock a little bit, so 200 megahertz more, and we'll see how much power it needs more. Okay, so we didn't overclock the GPU yet. That's something we can add in a minute. Not that we're gonna get really far with this card, but
Prime.
yeah, sorry.
Yeah, I saw you like,
Where is it?
it was green.
Yeah, I need a green icon. Is it already started? Yeah. Okay, here we go. Small FFTs. And go. Yes.
Okay, let's see what happens with NDI.
Let's see what the meter
Whoa,
is showing.
800 watts,
I
I
saw
saw.
804. NDI is struggling. On
No,
my,
it's still moving.
yeah. Sometimes you see some drop frames, but
Yeah.
on my monitor it's still fluent, so I don't see any hiccups here.
Here it's also pretty okay.
Yeah.
Means we have CPU cycles left.
Yeah.
We need to go higher.
But you can see that the oh, my chart is not really is maxed out. the blue bar shows 190 watts power for the CPU,
Yeah.
which is a little bit more than the 115 we saw earlier. No, 140 would be the max. Oh, it's not that bad. But I saw it peak at in the wall meter at 805 or something. So that's why you need an 850 watt power supply. And a good one too, because it might spike just a little bit higher than 850.
We're using water cooling today, Bob
Yeah,
was.
it's the Core Liquid 360R.
Maybe I can show like this.
But it's reaching a high temperature, so the CPU is running at 90 degrees now.
Good, I want to go out with a bang. Overclock the GPU.
Overclock the GPU, yeah, very easy. We just go to Afterburner, and then we can only go up to 102. So
3 looks like.
3?
It looks, yeah, it's
No,
really
it's
small.
a 2. It's a 2. I cannot
it's
make
2,
more
sorry.
out of it.
Yeah.
So now we see the GPU go up to 380 instead of 370. So that's the 10 watts more. So do we see it at the wall? No, the 10 watts is not really making much of a difference. Where is my prime? Is in my tray probably. Yeah, there it is. So this is about maximum power we can draw from this system without manual overclocking.
But I
So-
left a surprise for you. I have an RGB SSD over there.
Oh yeah, we have this one.
Maybe main.
This one, yeah.
That should also draw a little bit of power. Maybe connected. You have SATA cable?
Yeah. I have a. But do I need to run it or just connect it to the power?
But I want to see 900 watt.
It's not gonna do 900.
Come on.
No. But it's doing RGB, so it makes it fast. right?
HyperX SSD, cool.
Wait.
Okay, more power? No. Should I give some more keyboards and mice or something? I mean, 2 and keys power draw.
I have another fan.
Some fans?
But it's true, if you put more USB devices on, it's gonna draw power, but most ports are limited to maximum between 5 and 15 watts, so it's not gonna, it's gonna take a lot of USB devices to go until 900 watts.
Yeah. But if we would have used a GPU with a power limit of 450,
Yeah, it will definitely go over 400, the graphic cards.
and then the power supply above 850.
Yeah, then I would recommend more than 850. Yeah. Yeah.
Yeah.
Yeah.
But
If you want to do overclocking CPU and GPU at the same time with a system like this, or even bigger CPUs, then definitely go with a higher power supply. So
Yes,
1K or higher would be recommended.
it's the Kingston RGB SSD.
Yeah, that one's
Nice.
it's not heating up yet, but we saw it. Yeah, get quite warm.
Yeah, that's a good one. USB Type-C power delivery.
Not included
Fat
on
Dog
this
8.
motherboard.
Oh, this motherboard doesn't support that.
No,
That's a pity.
Maximum is, I think for this
Yeah.
USB is 15 watts.
Add the Intel Cryo cooler for another 300 watts.
Yeah, that's for sure. Yeah,
Yeah.
yeah. Tech or Peltier elements will draw a lot of power. Yeah. But if you're into that kind of stuff, then you will probably go for a higher power supply anyway. So 1K or higher.
You
yeah.
really don't care about cost and
Efficiency.
No.
Or if you want to do like 2 GPUs and do 3D rendering, then also you need a much stronger power supply than the 850. At least if you do two 3090s or something.
So, conclusion of today: no smoke
No.
because we didn't have enough USB devices.
No, it would just shut itself off if.
Okay, good.
But
good.
we're getting close to. At least we're going over the limit of the 750, which was recommended for this GPU.
Yes.
Yeah. But yeah, it's overclocking, and the thing will do extreme loads
We
like
need
Firmark,
LN2.
which is considered a power virus, and Prime 95 is also considered a extreme load, especially in the AVX one.
Okay, you want to show something more?
That's about it. For
Yeah.
me.
So then I'm going to do another lucky draw
Okay.
before we say bye bye.
Okay. You can definitely feel the heat coming out of it. But it's doing 370, 380 watts, so yeah.
Yeah. Yeah, that's what I like in the winter. If I don't have a heater, you play some games, then it gets warm. But
Yeah.
in the summer, it's not recommended. Let me see. So, the last winner for today, Stay V. Stay V, congratulations. In the coming days, we will send you Assassin's Creed Valhalla game code. Enjoy it. Also for all the other winners, you will get it in the coming days, maybe next week. That's also coming days for us. Yeah, so let me check this. Next week, I'm not allowed to talk what we're going to do next week. I just got this like description, changing the game.
I have one more thing maybe I can show.
Yeah, you want to show more? I think all people already left.
Oh, okay. Then,
No, doesn't
then
matter. Show us.
Yeah.
Fire.
No, I just want to show.
You see, people are saying GG.
We're overclocked the CPU, so
I don't know what change the game is. They just told me this. Just change the game there. Probably something NDA. We're not allowed to talk about it.
okay. So we're over.
We will send you an email if you want a game code. By email, yes, correct.
So normally 5950 does about 10,000 points, maybe a little bit more, like 100 point more on the Cinebench, and at that time it will draw roughly about 130 watts, something about that. And let's see what happens if we do Cinebench now. So let's see what the score does. Please remember that NDI is running in the background, and I also have the HW Info 64 window open, so you won't get the best score, but you can see that the power is going up to 180 watts instead of 130 watts, so 50 watts more. What kind of performance will it give? So it will give you 500 points extra. That's not really extreme. That's not a lot. I don't know in percentage, but it's...
Sorry, what?
We have 500 points extra on a 10,000 point score.
You cannot calculate that?
No, it's too difficult.
Anyway, that's for next week. That's easy.
Yeah.
Yeah. So
So that's about 5% with 50 watts. More.
exactly.
Yeah. Okay.
Yeah.
But if you don't run NDI and if you don't run HW info in the foreground, then it will go just above 11,000 points. So instead of 10,000, it will get 11,000 points.
Yeah, so I mean, we're going to cut Ruud off because he can continue talking with his benchmarks. He loves this shit. Sorry, stuff I said.
Yeah.
Anyway, next week, change the game. Wednesdays, 25th? Yeah, 25th.
Okay.
Same time. Without me, without
Without
Ruud.
me.
And we're not going to say who it is because then you know what we're going to talk about. Anyway, thank you all for joining. Really appreciate it. Also for all the interesting questions. I hope you got a good answer for us. Thanks. Enjoy your day or night, wherever
Thanks.
you are.
Bye-bye.
Thank you. Bye-bye.